What is up, party people? Right, okay, so I figured I owed it to you. You know, maybe, just maybe, we'll have a more of a structured learn about something stream. So guess what? Today we're gonna learn about something. Last night out on Jose's, they were talking about a SpaceTime, and it actually really did kind of make me wonder. Think that's actually a really good conversation to be had, and I was surprised that a lot more people didn't have that conversation going on. I don't know why the chat is not working. Let me make sure I have the right one. It's always something. I got the meetup already going on. For all the people that did want to join, if you are part of the bunker, the link is there, and that way you guys can jump on if you guys would like. Let me make sure I got the right chat up. There we go. Chat should work now. Boom. Oh, we'll see. Chat may pop up out of nowhere. Kind of get the whole bot thing going on. Didn't do the bot. Forgot that part. Let me get into the chat and say what's up to everyone. See who's all out there. Once I do this last thing. All right. All right. What is up, Peter? What's up, they and them? Barney? Yeah, they and them, Barney. The links in the chat are in the bunker. If you guys want that, I just put it in there a little while ago. John has already joined me here. What's up, GPS? What's up, No Name? What's up, Jose? And we're gonna jump into it. Digital, I saw you out there, my friend. That's it for now. Perfect. I know I kind of just jumped on too. I didn't even give you guys much time to build up to me getting here. Okay. Well, let me see. Where is that chat? There it is.
Shout out to the people in the chat. Go ahead, Sean.
What's up, Jose? What's up, Sean? What's up, they and them?
What's going on? Yeah, I wasn't prepared either. I joined and I thought I was going to be on mute. I figured there'd be many more people in here. So Sean had a little conversation with my son.
Yeah, it was fun. Sometimes it was actually better than a lot of the conversations we have in here. What's up, people?
Yeah. I mean, he asked quite a few questions.
Hey, yep. I think I gave him good answers. I think.
Yeah, good answers, and I was trying to play the UN. as usual.
All right. So on last time on Jose's, they had a conversation that I've actually liked to get into. It was space time, and it seemed Montreal and a few others didn't want to grasp the concept of it. So I figured, hey, since we've had so much fun over the last 3 live streams, how about this time we get a little serious? So I was like, okay, cool. So let's talk space time. I have a video that I queued up. I was gonna play it before I opened the panel, but then I changed my mind. Probably gonna get a strike for it. I'm not really sure, but either way, we're gonna end up watching it for a second. But hey, what's up, Barney? How you doing, sir? Got to guys. Got to take yourself off me, guys.
Of course, Barney is here. He's the master of. He can give an explanation that can be understood better by many people.
Oh,
Thank
yeah.
you, Barney.
Oh yeah. So I think the number one thing when we're talking space time would be for the just for the terms and the concept of what we're talking about. Time on a watch. Throw it out right now. We don't need it. We're not talking about that. Yes, that is a man-made thing, but it only measures what we're going to be talking about, and I don't want to have to go back and forth so many times in it. Would you guys agree that what we're talking about is not time on a watch?
Yeah, I can agree with that. I think that really quick. I think the space-time topic. I think the space-time topic came out yesterday because I think Davros mentioned. Yeah, fun fact. Do you know that Earth rotation around the sun moves in a linear fashion or linear vector or something like that? And I go like, please tell me more. And that's what I started. I think somebody mentioned, yeah, but you have to put yourself out and look at the bending of the space time, something like that. It evolved to that space time, and it's a concept I try to grasp. Even on Pace Shields, which is he's a very smart guy, and he was deep in. He was processing. Slowly his thoughts and gathering what he wanted to say. At the end, he agreed. He said it's still a concept that is difficult to grasp and explain. So yeah, I'm interested in listening what you guys have to say.
Well, I think it's definitely difficult. The idea of that fourth dimension being a thing, I guess. Barney, where you at, man? Just were supposed to save me.
Yeah. To me, it kind of like when you say space time, the word time kind of confuses everybody because everyone thinks of time as time on a watch, and like you just explained, you have to kind of forget about the time aspect of it.
Kind of like this.
Well, I think.
Go ahead.
Well, I was just going to say, I think it's going to be harder to figure out, to grasp the concept of space-time if you can't imagine three-dimensional objects.
Oh yeah, that's going to be a problem. This is the best thing I could show you to idea of what space-time is. This is it right here. This is as simple as it gets. This is the only way you could probably explain it to somebody with as few words as possible, in my opinion. Do anybody guys disagree? Agree?
Talking about this picture right here?
Yep, picture I'm showing right now. I think that's the best way. Yeah. That's the only way you can really. If you were just going to show someone one thing and say this is space time, this is what you'd have to show them.
I don't get it.
You don't get it?
Nope.
All right, let me get the handy dandy paint crayons out. I can give you a pretty good example of it.
I mean, it could get more dumbed down than this sign, but still, I don't understand the concept on where do you throw space-time with this illustration.
I'm going to show you. Gotta remember, I gotta show everyone else what I'm looking at too. Which one?
So the pole would represent the present, correct?
Yep.
Okay.
Where's my little crayon thing? Here it is. So, exactly. This isn't right here. That's now. Right? So anything, so we'll start right here. Anything beyond that point does this on an imaginary graph. So far, so good. Let's see. Here's a little imaginary graph right here. That's a shitty line right there. Imagine those lines are straight, people. You kind of have a bare idea of what we're talking about so far? Nope.
Yeah, I'm watching. I cannot talk a lot. I know. I think my audio
Okay.
is a little crappy, so I'll keep listening.
Okay, yeah, no worries. Okay, I just wanted to make sure. So, wasn't sure if anyone was going to ask questions. Okay, so basically, we'll start over and we'll do it like this. So, from we'll use from my birth, which starts right here in the middle, right in the middle of the cross. As I age, as time goes on, my little life meter or life graph will mark off like this, right? Exactly like the picture shows. This is the future. So right about here, that'd be my 20s, and it'd be like a point in time in my life, blah blah blah. But then it just continues on to the future. That's what the whole idea of it is. It's not so much at all your watch, how you're explaining it. See what you guys are saying in the chat. I hope that's a kind of a decent explanation. It's definitely not going to be the best one. That's why I did find a video that I think we should probably watch before get really deep into the conversation, because it'll probably be able to explain it a lot better than I will. Go ahead and stop sharing. Then I'll find that real quick.
Now, how much does space how much do you have to know about the fourth dimension to understand space-time? Do one have to do with the other?
Well, that'd be. I was ready for this, Jose. You share again. And see
I struggle with this. I did one or two shows dedicated to it a little while ago, like when I talked about I brought an older documentary and we talk about reference frames. I think that one was, and it was the space-time fourth dimension was introduced in that documentary.
See, I don't even like these ones, because even in these illustrations, so you can see kind of how it works, this isn't correct. If it was correct, it'd be so you see where the ball is, Earth, whatever. That would actually be this graph. The bending of space-time would actually be halfway in between. It'd be in the middle, and it would be everywhere. And
the thing with this graph is it's presenting it as a physical thing. Like, let's say magnetism. Oh, you cannot see magnetism. Let me pull a magnet and throw a bunch of little files, and you can move the magnet, and you can see, at least the magnetism. So that's what these diagrams imply, that it's something physical when it's really not.
It's definitely not physical, but because it is a dimension that, especially, imagine how hard 3D is for your brain to kind of to work with. Like, even though you think you see 3D, you just know what 3D is, and that's why you're able to use it. For instance, like the picture we're looking at right now, it's a 2D rendering, but you can physically make your brain see how it's a 3D image. Half my backgrounds are a 3D image. It's just the way it looks, right? But that fourth dimension, yeah, it's not something you can see, but it's something that if they couldn't even part way give you an illustration for it, then it'd be impossible to even have a stepping stone to work on of what it is. You know what I mean?
this fourth dimension is something that theoretically is there.
Well, no, it's there. I don't know. Would you call it physically
Theoretically, even scientifically
Well,
theoretical,
it's
but
not
it's still,
theoretical. It's not
yeah, it
theoretical
is.
because well, okay, well, if it was theoretical, then we wouldn't know for sure that the further up and towards space you go, the slower time gets.
I think this is a non-argument when you say it's not theoretical, because it is, and I think Barney will agree with me with this when he is able to speak. It's theoretical.
I most certainly will not.
Hey,
Hello,
Barney?
is my mic working?
Yes, it is.
Sorry for the delay. I was already in bed and my family was sleeping around me. And I had to get out of the house and it's raining outside. So I had to get to a place where I can actually be outside of the rain and still talk. That's why the long silence.
Hi, Barney. So the fourth dimension is not theoretical. Let me hear about it.
The fourth dimension is time.
Time as in we know time, or time as in...
Yes. So you gave an example of we know that magnetic forces are physical because you can take a magnet and throw out a lot of iron dust and see it align with the force field, right?
Okay.
You can do the same thing with the fourth dimension. Throw about a lot of clocks. Literally.
Yeah.
Throw about a lot of clocks and watch them tick time. And you will see that the time goes slower, like identical clocks that are made to run at an identical pace to each other. And as you move them to different places, they will start moving at different speeds.
But what about... Okay, so in the idea that I gave earlier, and when I've been looking into it, it makes it seem as if the time that we're looking at, 1 hour, 2 hours, 3 hours, you need to actually not use or think of it that way. Is there another way of thinking of it then, or am I wrong on that?
As with anything else, the unit that you use to describe time is kind of irrelevant. It's just convenient, right? As long as you're consistent about which unit you're using.
Okay, so if we're going to talk about time as in hours, years, and so on, then we need to stick to that, not go, well, you can't use it in space-time.
Any unit will work, and you can make up new units as you go along. You just need to keep track of how you defined your unit. But it is the concept that is underlying to all of those units taken together that is considered time, right?
Okay,
so
yeah, I get it now.
There are two kind of different philosophical theories of time, which are called the A theory of time and the B theory of time, right? What most people intuitively consider time to be is the A theory of time. Present is now, the present exists, and the present is pervasive all throughout the universe. There is a real now which permeates throughout all of the universe at once, right? Right now on I don't know, Sagittarius A, there is an event happening, which is happening right now, right? That kind of intuitively makes sense. So under A theory of time, that is now. Everything that is before it is the past. Everything that's ahead of it is the future. B theory of time is literally thinking of time as an extra spatial dimension. All of it exists. All of the past and all of the future coexist with the now. We are just moving through it. Like when you're walking down, I don't know, a street, right? At some point, you're at the beginning of the street, and then you're at the middle of the street, and then you're at the end of the street. Right? The things which you have already stepped across are spatially your past, and things which you haven't gotten to yet and you haven't seen yet are spatially your future. But they all coexist simultaneously, right? B theory of time says that time is like that. We are just being flung through it.
Okay.
Right? All of it coexists. The past, the present, and the future all coexist, and we are just moving through it. We have a velocity in the direction of future.
So then it's everything else around us is there, waiting for us?
Yes. The future is somewhere in the direction of future, and when we get to it, we'll see exactly what it is, and then we'll pass it by and move on, and it will become it will go behind us. It'll become our past, right?
So is that kind of what keeps simulation in the conversation? The fact that the way space-time works, there's a future, and we just have to get to it.
Yeah, and one of the requirements of Einstein's special theory of relativity and the Lorentz transformations. So you know the two common ones, right? You know about time dilation and space contraction. Yes. There is a third one which has to act with them and barely gets mentioned because it's the weirdest of them all, which is violation of simultaneity, right? Depending on your motion, depending on your position in gravitational fields, if we're talking about general relativity, things do not happen in the same order. There is no real now which is universal. The now that you're experiencing for the entirety of the universe is relative to your position and motion.
Kind of like this illustration, right?
Yeah.
Yep. Yeah, this is where I got this one from. I was watching a documentary on that.
So these are light cones or causation cones, right? Things that you might be experiencing now have to be somewhere in your past light cone. Everything that is outside of your past light cone literally has not had the time to reach you for you to observe it now, right? And things that you might affect through your actions that will be able to perceive the consequences of your actions are in your future light cone, which then expands at the speed of light in front of you through time. This is a space-time diagram. The vertical line is time. It is not space, right? That cone has one dimension in time.
Yeah, this is as if for one person, right?
Right. So one way to look at it is when you make an animation, right? When you make a video, you stack a lot of images one in front of the other, right? And then you play them at a certain playback speed to see the same events unfold in time. Yes. A space-time diagram, instead of doing that, stacks them on top of each other and shows them all at the same time, right? So if you were to look at this diagram as an animation, the past cone pointing at all the things which might reach you and affect you would be a very wide circle which was narrowing down towards you as you approached this moment in time, right?
Yeah.
And it would be just you, a point of you as a point particle at the point of now, where everything that could possibly affect you would reach its cusp. And then that circle would start expanding to show which things you might affect. So that would be an animation where time was shown as time. In this diagram, time is shown as space. So when you stack those circles that are narrowing down towards you and then expanding away from you, when you stack them up on top of each other, you get a cone, right? Which is wide at the base and gets narrower and narrower and narrower till it reaches a point, right?
So that's So that's the things you could do in your future.
The one behind is the things from the past that have access to you now, that might affect you now. So a star which shone a million years ago, for you to see it, it has to be within that light cone of both time and space, of distance in time and space to reach you. If it was at the same distance but more recent, then you wouldn't see its light now. It would be outside of that cone.
So many questions. I can't wait.
Right. There's one way in which you can kind of use this way of thinking to make it intuitive, which is, if it's really hard for you to think in 4 dimensions, as it is for everybody, just think in 2-dimensional space and 1-dimensional time. Make it one smaller. And that concept is called flat space, right? Imagine a world in which there is no up and down, only left, right, front and bottom. Everything has 2 dimensions. Everything sees each other as kind of cross sections, lines in that. You as a 3-dimensional being can look from above and see them all move around. You can see inside them, right? If there is a being which is a circle, when that being looks at another being, all it can see is the edge which is turned towards it. But if you're looking from the 3rd dimension from above, you can see its full circumference and everything that's inside it. So
like
for a fourth...
you mean kind of like looking at a chessboard with chess pieces. You see the roundness of the chess piece, but you also see the like what makes that chess piece on the inside of that, right?
There's a great clip of it in the original Carl Sagan's Cosmos, where he goes through describing the concept of flat world, right? And if you really want to get that concept, that's a really good clip to watch, and I'm sure you can find it on YouTube. But B theory of time then says, instead of looking from above and looking all of those 2D objects in that 2D world, imagine time as being stacks upon stacks of that 2D world on top of each other. As something is moving left, it is leaving a trace through time, through the spatial dimension of time. Like, kind of, if you have a circle moving around that surface, you would see it as a tube curving around, right? I don't know if I can paint the image vividly enough with just words.
Are you talking? So I found the Carl Sagan Cosmos one. It's about 7 minutes. Is that the same one?
Carl Sagan Cosmos Flat World. That should be the one. Yeah.
Yes, it says Cosmos Carl Sagan 4th dimension. I can play this one.
Dude, I got so many questions. Let me throw a few. A little ramble some questions for you in while you do the research. When, where, why do we learn this theory and concept of 4 dimension and time? Why and where do we apply this in real life? What does it require to learn these concepts and theories? I don't understand anything of it because it's a theory, and you say in the beginning it's not a theory, but you keep repeating theory. Even time, I didn't categorize it as a theory, but you yourself, you say it's a theory. Now we got space-time theory, we got the 4-dimension theory, and time as a theory. So I hate to be troll comments, but I love when I'm right and I'm proven right.
Okay. What was your first question? How did we come to?
Learn? Yeah. When do we learn these things? What does it require for me to go learn these theories? Why? How am I going to apply it? Because if I want to learn, I want to learn about space time. Where do I go to study this, and why is the application? Why do I want to learn this?
You will learn it by learning physics, by learning classical physics, right? General relativity is part of classical physics. This is what made Einstein Einstein. That's why you know his name, because he figured this out. Why did he come to it? It was literally a logical necessity. It is not just a bright idea. It is the only solution to the problem. Every future solution that we find to the problem will necessarily have to include this, because this is the only way it works. So the problem is that Galilean relativity, Newtonian physics, describe things to a certain level and then stop. And when you get into researching electromagnetism, any electricity, anything like that, what Maxwell was doing, what Lorentz was doing, you get into trouble really fast because things don't work, because relativity cannot be applied. If Newton was correct, if Euclid was correct, if Galileo was correct, then our electronics would work only for a perfectly stationary person, right? Only while you were standing absolutely still in an absolute frame of reference, not moving in any direction, would it move as described by any laws. As soon as you started moving, you would need to change the laws. And that doesn't happen. Your computer works equally as fine on Earth, on a satellite, on a train, on a plane, right? Wherever you take out your computer, it works. Wherever you take a circuit, it works. Wherever you make an electromagnet, the force of magnetism is equally proportional to the charge that is going through the wire, and that cannot be. That literally cannot be in Newtonian physics. So that was a paradox. That was something that was deemed unresolvable, unexplainable, just whoa, right? And then Einstein was the first person who dared to say, well, maybe our notion of space as this fixed thing which never changes and is universally everywhere the same, and time as something that just ticks at the same rate for everyone in the universe. That notion that there is a now on Sagittarius A relative to you, or right, that there is an event which is happening right now on a very, very distant star. Maybe that concept is wrong in itself. So all of those equations that Maxwell wrote and all of those explanations that Lorentz came up with in his model of electromagnetic space, they all require a constant speed of light for everybody. No matter how fast you're moving, no matter which direction you're moving in, the speed of light, the speed of causality, the way that things can most rapidly affect each other is a constant. The only way it can be a constant for everybody, regardless of how they're moving, is if their space and their time were flowing differently depending on how they moved. And then Einstein went and found the math to describe how that happens. That was special relativity, right? And then he further explained how that happens, how that explains gravity, how that interacts with gravity, how that manifests all of the previously known laws that couldn't be made to work together, how it makes them all work together using this explanation. So the only way an explanation works is this. It is logically necessary that it is like that. It is that part of it is beyond a shadow of a doubt, right? That is describing reality. Now, we might be wrong in details. We might be missing concepts of things that we do not yet know, of phenomena that we have not yet encountered.
I hate to interrupt, Barney, but when you say we, it's the very smart people like you that understand these concepts and are able to explain it to peons like us, right? Because it's not me. I don't understand shit of what you're saying. And 90% of the people in the chat, they say, yeah, Barney is right, but I know most of the people don't understand. So when you say we, you mean the top of the food chain people that understand it, right?
I'm talking about the legal, reasonable person, right? A person who is familiar with all the known facts and has the ability to just apply logic to them. When I say we, I mean the human race. I mean everybody who is willing to sit down and actually dig into this.
And at least half of the population will never question this, will never research it. So, I mean, yeah, it's humankind, those people that just want to learn about it like you did, you know?
Yes, and if I never sit down and learn French, I will not know what a word in French means. That does not mean that it is questionable, therefore, what that word means, right? If you, the legal term of a reasonable person is literally if you know all the known facts, all the facts which are reasonably undisputed, right? If you go and learn this thing and read up on it and do the math and do the legwork to figure out what it actually says and why it says it, you will agree with me.
Well, if I learned it like you did, and I said, this is how the theory works, and go through all the books and learn all the equations and learn the different theories and which one stands stronger, I will be like very smart. But now, that being said, it's something that I learned and I cannot test it by myself any way, shape, or form whatsoever. Unless you tell me you can test it by yourself, I'm listening. Let's see.
You already know the example that I'm going to give. You can test it by yourself by using GPS, right? You can use the products of that work. You can use the transistors in your computer that you're using right now to talk to me, which use quantum tunneling and use relativity to transfer energy from place A to place B. You can use electromagnets. You can use all of those things necessitate general relativity to be correct. To be sufficiently correct, right? Not to be perfectly precise and exactly, not to be a theory of everything, not to be the explanation for everything that exists in the universe, but in which it does describe, in that it is necessarily correct. Right? In the same way that Newton is necessarily correct in that which it does describe, like in your local frame of reference, on your time scales and your level of relative speeds that you experience reality in everyday life.
Barney, can I ask you a question? This is only a question. This is not a point for debate. But would you say that Einstein's theory that that time is a fourth dimension, would you say that's a hypothesis or a theory? Because if you look at the strictest term of definition of a hypothesis, right, it says a supposition or proposed explanation made on the basis of limited evidence. Okay, that's the key word, limited evidence, as a starting point for discussion or starting point for further investigation. Then if you look at again, this is only the strictest definition of a theory. A theory is the supposition or system of ideas intended to explain something, especially one based on...
1 sec, guys. I'm gonna PMARS the hangout so that he won't be able to annoy anybody. About 3 seconds. Hang on. Give me... All right, here we go.
with I know you're joking with it, but you know that. But if you're talking about it, I'm talking about in layman's terms. What I'm trying to do is to get you to actually break it down into sort of more layman's terms. Is this a theory or is this a hypothesis? That's what I'm trying to get at.
It's a scientific fact.
Fact.
Barney.
Yes.
Okay.
It is a known truth, and it is a truth based on deductive reasoning, and like that's the word that I keep using is it is necessarily so, right?
But you cannot call it a law. You still have to call it a theory. Huh?
There's no such things as laws anymore.
Yeah. So that's what
theories do not graduate. Theories do not graduate to become laws.
Right.
Laws precede theories. A law is just a recognition of a regularity, that something is ordered, that something is maintained and kept, that something is never lost. There is a great mathematical description of physics by, I forget her name. Her last name is Noether, something like that. It's spelled Noether, Noether.
Oh, I thought you just about to say Etherbound then.
Who figured out that all laws and all symmetries and all conservations are the same thing, and found a way that, like, she has mathematically proven that if you see a regularity, that regularity is the same as a law, which is the same as a conservation of some quantity, which is the same as a symmetry of nature, right?
So why is the fourth dimension not really like a common known fact? Why were you not using the fourth dimension? Because obviously we talk about 3D and all the rest of it as well. So why is the fourth dimension not really a generally discussed option? Why is it not a generally discussed fact?
It is.
That's a simple one.
You use time all the time. You use the concept of time.
I understand that. We all know what time is. But why is not everybody actually saying what I'm trying to describe? What I'm trying to get at. Why we're not saying that? Okay, right. We're measuring time. Therefore, that is the fourth dimension. That's not really what I would say that people would conceptualize as the fourth dimension.
Are you trying
in
to
space time?
Because people are uneducated.
Space time
Because these things are hard to think about. Because our brains.
I disagree.
because our brains conceptualize the world as a 3D spatial environment and keep time as separate because we do not have direct access to changing our momentum through time.
Okay, yeah, that
Okay,
makes
Barney.
So you
Barney,
accept
I
that
got
criticism on page shills when you are called uneducated, not understanding this concept of space-time?
Well, no, I think that's a fair thing what he's actually saying, because I didn't understand it myself, Jose. So it's not that, you know, what he's saying, Jose, is it's not so much what they're talking about is
But you say you didn't understand it. That means you understand it now, right?
Yeah, no. What I'm saying is, he's not saying is he's not saying it's a lack of intelligence, it's a lack of education in terms of what we've actually been taught. That's what he's saying. So
it's a lack of attention. So when I say that, I don't mean it in the pejorative term of you're uneducated, as in you're dumb or you haven't learned enough at school. It is not. That part is not commonly taught to children at school. It is taught at college level physics, right? It is taught like you will get the first barest glimpses of general theory of relativity in Croatia in the last year of high school, right? As a preparation, and that depends on which high school you go to, right? Same way.
Really quick question to Casual Spaceman. You said you didn't understand it. That means you understand it now, or you misspoke and you mean you don't understand it?
No. I understand the principles of what he's talking about. I don't understand the theories of relativity as a whole. No, absolutely not. I'm not saying that at all.
So you don't understand it. You say you didn't understand it was a misspeak from.
I understand that what the fundamentals he's talking about. That's all I understand. I do not understand the rest of the theories of relativity. I am not claiming that at all.
Thank you. I like those play of words. When you say you didn't understand, but you actually mean you don't understand. Thank you.
Well, and if I
my math, that's not what I'm saying at all.
When we talk about understanding, right? There are many ways in which I don't understand it. I cannot visualize 4 dimensions. I cannot think in 4 dimensions. I do not think of time as a spatial dimension. Like when I go to the store, I don't think that I have to go through 40 meters of time to get to the store, right? Or 500 meters of time to get to the store. That's not what I mean when I say I understand it. I understand it in the sense that I've done the math, I've gone through it, I've picked apart everything that didn't make sense to me and worked through it. And when I worked through it, all the answers, all the conclusions were correct. All of them, all of the things that appeared to me to make no sense, give the right answers.
Okay, I have a question.
Well, okay, go ahead.
Yeah. So again, also in this 4th dimension, let's presume that you are not a human being. You are an atom or electron or whatever particle or anything you want to be. Are you going to experience those 4 dimensions?
Yes.
In the same, so we do not experience things as though we're atoms. We experience things cognitively through our brains. You can only experience things which your brain can deal with. Right?
Yeah, I'm saying you're not a human. You are a photon, for example.
Yeah.
Yes.
A photon does not experience anything. A photon does not experience time at all.
Oh, that's complicated.
Right? For a photon, everything is instantaneous because it is moving at the speed of light.
Electron?
An electron has mass, yes, it will experience both space and time. Whether it will experience something more is possible. If string theory is correct, it might experience 11 additional
secret
dimensions. Yeah, dimensions, but those are highly speculative. Those are very highly speculative.
Yeah, I'd like to shoehorn a few words in here if I could.
Go ahead.
Okay.
Okay. Well, go ahead, finish, Khalid, whatever you're going to say.
Yeah, okay, last sentence. I hope if you can write a small story written by an electron experiencing these things. I hope so. So it will explain a lot of things for us.
Okay, I differ with Barney. I disagree that that it's necessarily a matter of education. I think it's part of how our minds are constructed. We do not live in a four-dimensional spatial world. So for us to deal with reality on a four-dimensional or higher dimensional level, we're just not constructed to deal with it. That's like trying to run a 64-bit program on an 8-bit computer. It just doesn't work.
I agree with that.
We can't think in the fourth dimensional world. I think that's basically what you're saying is, okay, we can debate whether we live in a fourth dimensional world all day long, but what most of us can't do is actually conceptualize or think of a fourth dimensional world. So I would disagree with that.
So Shills, what you said is I'm completely in agreement with that, and I think I've said it during what I was saying before, right? That's part of when I say that I don't understand it, I don't understand that bit. I cannot imagine fourth dimension spatially. I don't know what's a direction that is at right angle to both up, down, left, right, and front, backwards is. Right? I cannot visualize that. I cannot visualize that. Right? I don't understand it that way. However, when I say that it's lack of education, it is really not meant as an insult. It is meant as that information is not made as available and explained as well and communicated as well through the education. There are some attempts on educational websites such as Brilliant and on YouTube channels and in popular science books that try to convey this to the layman in terms which might be understood without going into the math, right? But that is too small, and for a century after the discovery was made, it is kind of really not sufficient to educate people. And if you sit down and kind of go after it and make a determination to just learn what is known, why it's known, what does it mean, what are the consequences, think it through, you can learn it. It is not hidden information. It is not unavailable to you, right?
Okay, finishing what I was trying to say, it's not something that we necessarily are designed to work with biologically. It's not in our physical world. Therefore, it's something that we have to really stretch our minds in order to understand even the basics of. And then if you want to understand it on a deeper level, Barney, you've got to mind your breathing, partner. You're either doing an obscene phone call or you're running a marathon. But if you want to understand it on an even deeper level, you've got to dedicate a very substantial quantity of time to study the mathematics, the physics, the understanding before you even really start grasping it. And most people don't have that much time on their hands to dedicate to those topics. That's why I'm okay just leaving a lot of the stuff alone and just saying, you know what, I have a basic understanding of it. I'm okay with that.
That's fair enough.
Well said, Shills.
For me, it was not a question of time, and I don't think it is a question of time for anybody. It's a question of curiosity, whether you care to understand it. If you're fine saying, "Oh, that guy took the time to understand it, and he says it, so I'm fine with that," that's yeah, sure. If you're fine with watching a PBS documentary and saying, "Oh, they told me it's so," and that's fine for me. I was too curious. Every time I watched one of those things, it opened up more questions than it answered, and I wanted to figure it out. And it wasn't, "Oh, do I have the time to do this?" I didn't watch TV didn't watch movies. I didn't watch series. I read books. I learned the math. I watched college lectures, and I sat for hours in front of a computer or in front of a piece of paper and worked it out. This is impossible. This will lead to a contradiction. This will lead to something that cannot happen. Oh, it's not that it will lead to something that cannot happen. I had a wrong idea about it. When I work it all out, it all makes sense. It all comes back to the same reality that we live in. This thing really does describe reality, right?
Right. Barney, your explanations of space-time as something that's actually congruent to how things happen everywhere. You know, it's not just where we are. It happens to the supernova that blew apart 5,000 years ago. It happens to the evolution of our solar system, the evolution of the galaxy, the way it revolves, what happens to it, when it moves, how it moves, the intervals between when one thing moves to another point. And everything like that everything is intrinsic in that space-time. I mean, using the space-time interval equation, I'm just starting to try to understand that damn equation. And my God, it's only like what, eight symbols in length, but trying to work out what that negative symbol in the middle means is totally confusing.
I know. It's time.
Yeah.
The negative symbol in the middle is time. Right.
Yeah. How it is that your past was somebody else's future. That sort of thing. That's what Shawn was alluding to with his post and his two signs. So that someone's past is actually the future.
Oh, that gets somewhat deeper into connections with quantum physics and causality, and like that part gets, like, if you don't get general relativity, quantum physics gets way more complicated than that. But yes, one way of solving Dirac's equations, of looking at what Dirac's equations, which tell us that antimatter exists, is that it's just normal matter, which has the momentum through the dimension of time in the opposite direction. Literally, that our future is its past. Right?
Yeah.
And
I've just started getting into that stuff, and it's just mind blowing how much you have to read to get the concept of that, let alone to start understanding the equations.
I have a little question, not very big. It's about time dilation and stuff like that. Is it okay, Barney?
yeah, I'm fine with anything.
Yeah. First of all, I don't know what's the speed of an electron about the atom. So is it like big? The average, like 0.5 the speed of light, something like that?
I don't know.
Okay. The question is, if we go to a certain speed and that electron is going in circle around its atom, then at a certain direction it will be moving at a higher speed, and then in the opposite side it will be at a lower speed. So how does the relativity react to that? This is the component of the matter that we say it's going to need a lot of energy and stuff like that. So I don't know if you get my question.
Okay, I think I get your question. It's a broader question of, can we add up speeds to more than the speed of light? Like if I'm going at 1 kilometer an hour below the speed of light, and then I accelerate by 2 kilometers per hour, will I be going faster than the speed of light?
Yeah, that electron in the atom could be.
Like if we accelerate that atom to very near the speed of light, is it possible that that electron, when it's moving in the same direction as the atom, will come closer to the speed of light or overtake it? Now that is the core of Einstein's theory, where he says that the speed of light is constant for everything, no matter which speed it's moving at. So if you're moving at 9.999999999 point of the speed of light, the speed of light to you is the same as it is to me.
Yes, but if I'm going at that speed and I throw a rock in the same direction, so
yes, the speed of light to that rock will still be. You would still have to throw it at 300,000 miles per hour, whatever it is.
300,000 kilometers per second.
Kilometers per second, for it to go faster than the speed of light, right?
That's relatively to me, but to a stationary observer will see that this stone is going far beyond the speed of light.
No, they won't. Because what you're talking about is Galilean transformations. Galilean transformations don't work, right? That is, you have to use Lorentzian transformation. So here's maybe a clearer example. You are standing in the middle, perfectly still, and there is a spaceship moving at 1/2 of the speed of light in one direction away from you, and there's another spaceship moving at 1/2 the speed of light directly away in the opposite direction. Then surely those two spaceships are moving apart from each other at the speed of light, right?
Yes, okay.
Wrong.
Oh.
Under Lorentzian transformation, those two spaceships are moving apart from each other at 0.75 of the speed of light.
Oh.
Right? No matter how much you can accelerate at a constant rate infinitely long and never reach the speed of light.
Okay.
What about
I kind of get it.
What about a Bose-Einstein condensate?
What about a Bose-Einstein condensate?
They used it to stop light.
They use it to, yes, but that's just refraction. You can slow down light. So, okay, what does refraction do? Light is an electromagnetic wave. Waves, when you have an electric field oscillating, it will cause a magnetic field to oscillate around it. When you have a magnetic field that changes its value, you will have an electric field oscillating around it. That propagates light, but that also affects that also affects all of the charges in its ways. So if there is an electron somewhere, if there is an atom somewhere, if there is a proton somewhere, in the vicinity of that photon moving along, those oscillations in the electromagnetic field will make that charge oscillate. It will move the charge. That charge will then be changing the electric field, which will be changing the magnetic field. Those things, you will have two changes in the electric field, two changes in the magnetic field, the same magnetic field, the same electric field, which will interfere with each other. When you do Fourier analysis on it, when you Fourier synthesis, when you combine all those waves together, the wave that you get looks exactly like a photon with mass, exactly like a photon which is moving slower than the speed of light. Depending on the interaction with the charges, you can slow down light provisionally much. If you push it through Bose-Einstein condensate, you can slow it down to something like 40 miles per hour.
Okay, what I was trying to say early on when you started telling all this was I was going to ask you, are you saying this for my benefit or someone else's?
Did you ask the question about the Bose-Einstein slowing down light, Bose-Einstein condensate slowing down light?
Yes, and I was being facetious.
And I answered your question as though you were not.
And I tried to stop you to say,
and I
if you're
would
saying
not
this,
be stopped.
Yeah. So you are the Eastern European rumpus.
Yes.
By the way, I understood why this electron and atom thing won't work. And may I explain it again?
Go ahead.
Yeah. Okay. So if let's say that I'm moving in a train at the speed of light minus 10 meters per second, and that train carriage is 20 meters long, and I'm going to throw a stone that will, for me, travel in 1 second. This means that this stone, or that what I thought, that the observer would see that stone exceeding the speed of light. But for the observer that's stationary, the carriage of the train is not 20 meters, it's almost zero.
It is almost zero, and that 1 second that you're measuring will not be a second for him, right?
Yes, okay, I got it. Yeah, that's interesting.
And all of those things will conspire so that you can approach the speed of light, and as you approach it, as you get nearer to it, it just moves away from you because it is constant for everybody, equally the same. Doesn't matter how fast you move. When you convert it to your own frame of reference, it will look the same. So that like ties in. You've heard the phrase or an explanation that as you approach the speed of light, you gain mass. You become more massive, right?
Yeah, I've heard of it.
So that is relative to a stationary observer, right? Because he sees you, like if he sees your fuel gauge and he sees how much power your engines are outputting per second, he will see that you're still outputting the same force as you were before, but your acceleration will be decreasing. Since the acceleration F equals ma, right? The acceleration is inversely proportional to the mass, right? That means that if the force is the same and the acceleration is decreasing, that means that the mass is increasing. So for a stationary observer, it will look as though you're increasing in mass. For you, it will look like you're just infinitely and indefinitely accelerating at the same rate, never reaching the speed of light.
It's the first time I hear this. I think I may need to listen to it like 15 times more to fully understand it. But yeah. But hold on, I'll sleep on it.
That's okay.
Yeah, the electron moves at around about 2,200 kilometers per second in a hydrogen atom.
Thank you.
Yeah. Okay. So to get a electron to 90% the speed of light, it needs 220 electron volts, and you will never get it to the speed of light because it becomes too massive. Right. As Barney just said, because the acceleration decreases due to the mass increasing.
If you're standing next to it and observing it, it becomes more massive. If you are the electron, then your time just dilates. The universe around you starts moving faster and faster and faster and faster and faster. Right?
Mm-hmm.
So how could we resolve that? Is there a way of resolving that at all?
It is resolved. It is resolved through special and general relativity, right? That is the resolution. It shows that those two things are identical. That those two things are not two different things, but that our notion of space and time is the wrong notion. That the correct notion is the notion, like the correct measurement of distance is a space-time interval. And it's somewhat misnamed, right? It is neither in space nor in time. It is the thing which is conserved for every observer wherever they are, from which you can derive for each observer what their unit of space is and what their unit of time is. Not what their measure of space is and what their measure of time is.
So really, the chances are in the history of, even just within the history of humanity, or at least intelligent life on this earth, that we can expect even the same sort of time span that we're talking about now between now and the future, the chances are we probably would never actually solve that theory, or solve how we can actually crack that in order to, travel the speed of light. Because it seems too far along to actually sort of be able to even conceptualize it, let alone solve the issue.
So yes and no. There are ways in which you could get to a place which was more distant to you in shorter amount of time to you than seems possible by the speed of light. The Cuvier drive, which is basically literally warp from Star Trek, where you don't move at the speed of light. You move always slower than the speed of light. You just make the space around you move to get you to where you're going.
So we're bending because we're bending space and time. So therefore we're bending time. So therefore we have to be able to travel faster than the speed of light if we can bend time. Is what
you never exceed the speed of light. You're never moving faster than the speed of light. You just get to where you're going.
I'm only asking that because that's the big question about space exploration is, going beyond our solar system, because obviously the nearest star system to us is 4-point-something light years away, which is a phenomenal amount of distance. So in order for it to even get to the nearest star system, Alpha Centauri, we're going to have to at least get to or near the speed of light.
Not necessarily. So I've actually done this calculation either on Jose's or on Shawn's before. As you approach the speed of light, the time for you slows down. So that if you were going at the speed of light, you would experience no passage of time. For a photon, even though when you look at a star which is 1 million light years away, from our position, that light took 1 million years to fly to us. But that photon didn't experience any time. It just appeared there and then it was here, right?
Yeah, from its own position. Yeah, because obviously if you're traveling at the speed of light, as far as you're concerned, time is still the same. But those effects are useful way below the speed of light. So if you just constantly accelerate until half of the way to where you're going, and then decelerate the other half of the way, so that you're constantly experiencing 1 g of force that you have, right? I mean, the amount of energy you got to take to actually get even halfway, you then got to expend that energy to then slow down.
Yeah,
because
but
you want to get from A to B, otherwise you're just going to go past B and then go on to C. If that makes sense.
So if you're using that mechanism of propulsion, it will take you, let's say, 6 years to get to Alpha Centauri, or 7 years to get to Alpha Centauri, or something like that.
Yeah.
But that is when you're looking from Earth. When you're in that spaceship, only 3 years will pass for you. For you, it will seem as though you have reached it faster than the speed of light, right? Why? Because your time will be dilated.
Yeah, so that's even before you reach the speed of light, even close to it, let alone even half of it.
So if you want to go there and then come back and have useful information for the scientists which have sent you there or the governments which have sent you there, that doesn't really work. But if you are just trying to seed the universe with humans, I think that something like to the other side of the galaxy, it would take 15 years, and to the edge of the visible universe, it would take something like 16 years or 15 and a half years, something like or 17, something very, very, very short. Right, so you wouldn't need stasis, you wouldn't need any kind of generational ships. If you could just maintain your thrust, the same people that went on the mission would reach the edge of the universe.
Yeah, if you keep on accelerating to that point, yeah, I get that. Yeah,
because most of the passage there, you would be traveling so near to the speed of light that your time would be dilated enough to
yeah. From your point of view, yeah, I get that. Yeah, that makes sense. Okay, thank you. Appreciate that. Thank you.
Actually, Barney, edge of observable universe or the entire universe?
Edge of observable universe. We don't know how large the entire universe is.
Yeah. We don't exactly. Yeah.
Yeah, but like it's interesting though, because I know how you gave it a definite time of say 15, 16 years to get there, but wouldn't the fact that the actual universe is expanding over those 15 years, it'd take you longer to still reach that point?
It would take you longer in Earth years.
Yeah.
Right?
Yeah,
more time would pass on Earth, but it wouldn't be significantly more time for you.
It passed on Earth years in terms of what your reference point is. Is that what you mean?
Yes.
Yeah.
Right.
And if the rate of inflation is increasing constantly.
Come again.
And since the rate of inflation is increasing constantly, yes, things would be moving away from you faster and faster and faster as you accelerated towards them. Fair enough.
Jesus Christ, it's such a hard concept.
The best understanding we have at this point is that the rate of expansion is increasing. So it's getting faster and faster.
I see what you're getting at, yeah.
So it is increasing. We
Sounds
still
like
don't know.
Tale to me.
We still don't know how fast it's increasing. Not all of the observations are in agreement, right? We have several ways of measuring it. They all show that it's increasing, but they don't show it increasing at the same rate. So we kind of don't know exactly what's going on there. And there's been like a recent paper, a couple of weeks, maybe a couple of months ago, about the detection of the curvature of space, which was assumed to be flat. It now appears to be negative, meaning that space itself is a four-dimensional sphere. It is closed on itself. Like not the visible universe, but the universe as a whole. And that
I'm gonna concede my time to ask a question or two to Ozzie Montreal to explain to me from his understanding what he have heard so far. What have you learned about space-time, Montreal?
It's La La Land.
Everything Barney just said is sheer speculation, Jose. Every single word that he just said, somebody made it up in his head. It's unprovable. That's what I think.
What would need to be proved? What is an explanation for what Barney has explained? What's an alternative?
What's an alternative?
I don't know.
Do you even need space-time in the beginning to ask somebody else to give you an alternative, or is space-time put in there as a little bit of a gravy in the top?
No, they start off with an assumption, Jose, and then they demand of me to explain something. No, I demand of you, Barney, what you just said. Prove anything that you just said.
No,
Prove space-time.
Nobody's asked you to explain everything. Somebody just asked your understanding. Nobody's asked you to explain everything.
You would need to actually have an understanding of and an alternative to tell Barney what he said is wrong.
Nobody said anything about your understanding, only your understanding. That's it.
You want to know my understanding of what he said?
I asked him.
Yeah. That's
that Jose asked me, and I gave an answer. Now,
Okay.
if that answer isn't sufficient enough for you, ask me another question. I'll answer it for you.
And did we expect anything else from him? Honestly.
You mean to tell me?
It's sort of like, he's sort of saying that we're expecting him to explain everything. It's like, wow, come on, dude, Jesus Christ.
But I think the right way is to let Montreal ask the questions, because he's the one person that needs to understand this concept more. Myself too. I'm with Montreal on this one. I don't understand shit of this, and if I'm here in the call, it's because I need to get clarity, and Montreal will have the best questions. Now you guys are gonna kind of attack him a little bit because he just opposes all your main views. So that's what's a little sad about it,
Yeah, but
like
dude,
when a guy opposes your view, you jump down his throat and make him feel, unwelcome. That's not fair.
Yeah, Jose, you're asking the right questions to actually understand something.
No. Hang on. What it is, Jose, is where you're asking the questions. Montreal is telling us it is wrong. There's a difference between trying to understand something and trying to tell you how something works.
Exactly, Shawn. Thank you.
No, I gave my opinion to a question.
I also don't understand space-time. I barely understand time dilation and length contraction. That's all what I understand. But I don't know what is that space-time. You've been talking all time. I'm sorry to frustrate you. I couldn't understand it.
I'm with you on that, bro. Nobody understands it because it's a pile of crap.
There's no
such thing as space and time.
Montreal.
That's in one person's
imagination. I'm the one who doesn't understand.
It is simply the conserved quantity. It is that thing. It is that thing that if we measure time differently and we measure space differently, and we do, and that has been proven and demonstrated, there is a mathematical relationship which is the same for everybody, which is the space-time interval.
So, Montreal,
that's the only thing you can do, Barney, is go into your maths.
So rather than sort of like trying to ask questions to understand something, because you don't understand it, you just dismissed it as crap. Is that it? Is that all you've got, dude?
No, that's not all I have. Okay, but what I'm telling you is...
So prove that it's crap.
Hang on, casual, hang on. So Montreal, you said that what Barney keeps going into is the maths of it. Why wouldn't he? You understand that math is what gives us a better understanding of the observations that we've made to the theoretical science that we've constructed?
But it's not the maths.
I get how the brainiacs work, and I will concede that Barney has far more knowledge in various subjects than I do. That does not mean he's right.
Name what you talked about in maths. Name one equation that he mentioned in anything he said tonight. Anything, one equation.
He just mentioned maths before. That the maths explains it.
Name it. No. Before that, everything he was saying up to that point. Name one.
Casual.
Before that point, dude.
Can you show me some time and space bending, please?
Oh, come on, dude. How can I show anything? Can you show me a picture of the flat? Exactly.
He's of the zetetic.
How can I demonstrate
space-time bending? I've got one for you.
Christ.
Space-time bending, light going through glass.
GPS. Listen, some white-haired crackpot came up with an idea 100 years ago. Everybody bought it. There's no
typical
proof.
I don't
Get
understand
over it. There's no such thing as space-time.
GPS.
Get over it.
GPS.
Flat
GPS. Get over it.
I don't understand something I can't
Cody.
see it, therefore it doesn't exist. That is such a typical flat Earth response. Have you got anything new? Really?
You
Seriously?
see the picture there? You see the picture on the screen there?
Your
It's a
point of-
You
representation.
believe you live there? If you believe you live there, my
Okay.
friend, you're a joker.
Montreal.
See that whale there?
Montreal.
Okay.
You think you live in that ball there?
I've got a question.
understand or even try to understand it. You're just dismiss it because you don't understand. Therefore, it doesn't exist.
I want to ask the rest of the panel to give me a couple of moments. Okay.
Okay,
I
sure.
want to ask Montreal if he really understands that the whole concept of relativity and space-time has got to be taken into account when using the GPS system. Do you understand that?
I could give a shit about the GPS system. I'm talking about reality. You believe you live on a
I rest
ball.
my case.
It doesn't exist.
Oh, you have no case, Shill. You have no case.
Chat. If you're going to come with something this
You
debate,
have a story.
dude, not just dismiss it with nothing.
Casual.
Well,
Give
I
us
give
your...
a shit about what
Hey.
you've got to say then.
Wow,
And
man.
if nobody gives a shit about either one, then why the hell are we even here?
I heard GPS being
Listen,
mentioned since
If you
earlier
talk to
in
me
the
with
stream.
respect, I'll give you respect back.
What are
Hey,
you
guys,
doing? Just
I
because
have
you
heard.
come
All right,
here, just
casual.
because you don't understand it,
Can
therefore
we? Can,
it's it. Montreal,
Casual, shut your
Hold on,
yap.
hold
Okay,
on.
guys,
Hold on, guys.
everyone.
Hold on.
Yeah, relax. Go ahead, Sean.
Yeah. Just get 1 second. Okay, Montreal. Can I ask a question about what's wrong with GPS on in your eyes?
We're talking about the nature of the universe, time and space, and you're telling me about a GPS? Dude,
I want to chime in
you-
on this GPS thing because I heard GPS mentioned at least 3 times that you need space time for GPS. I don't understand why. How can you make me see? All right, this is how GPS work, and this is what we have to add the space time. Little what do you say factor on it. I need to understand this. I don't understand why you guys say GPS and space time go hand to hand. I need to understand.
they have a
and
clock on it and they say
get
there's a
there.
difference in time,
No,
Jose.
hang on, Jose. Have you ever used GPS and it says "hang on, trying to fix on your location"?
Yes.
If I could continue, Jose, basically GPS system works on a system of clocks. Time codes are sent to your phone or your GPS device or whatever, and then those time codes are compared from one satellite to the next to triangulate your position. Okay, it's like getting a 3 different signals from at least 3 different sources to show where you're located.
Yeah,
Okay.
I understand that the GPS will throw a signal and it will give me, because it has to throw a map, it has to give me the grid, and it uses that's a space, right? And then the time, it will make an equation, whatever, inside the little, and it tells me you're gonna get from point A to point B at this time. I see that as two different things, but I don't see it as space time, as this concept of the space and the gravity and all this shit.
Okay, I just wanted to make sure you got the whole thing that it operates off of time codes. Now, how this works is, Barney, you're breathing again. How this works is those satellites are orbiting at such a rate of speed that each day they go off sync just a little bit. So they need to be adjusted ever so slightly each day, so that they can maintain synchronicity with the other satellites.
I think it's more related because they are.
And that has to do with the
faster.
4-dimension space-time and the orbits of the planets and all this shit, yeah?
That
Just another story, Jose. Just another story.
Southeast Montreal, shut your yap, okay? I'm talking to Jose. Okay, you attacked me when I was asking you a legitimate question with respect, and you attacked me. Okay.
I did not. I never attacked you, Shields. You started.
I'm talking to Jose now.
Let me get.
Hey, excuse me. I just made a comment. Go ahead, Your Highness.
I understand, Shields, because I see GPS needs 2 concepts. They need space and they need time. But why space-time as this theory have to do, like the theory of the fourth dimension space-time and bendiness and all that. I don't see it as that one concept. I see it as the two. I see space and I see time.
Okay, because it's dealing with relativity, relative motion. Okay, or I should say
start with time
motion.
dilation. Time dilation.
You're not answering his question. You're I think that from his
go ahead.
From his perspective, you're just reiterating the statement. Right. So let's just go through the basics of GPS. What it does and how it does it, and why it's.
I couldn't phrase the question in a more coherent way, but I think Barney understands where I'm coming from. I see it as two different concepts.
So if I have a clock and I just send out the signal of that clock, just broadcast into the universe, what time is it for me now? And you take that signal and see how much that clock disagrees with me, and you know the speed of light, you will know how far away you are from me, right?
And this can be tested with these probes that have been sent tens of years ago, 20, 30 years ago, that are very far away? Or is this mathematical concept that we have to understand? Because they have to be tested, somehow.
Both. This has been tested in a myriad of different ways, and it always holds up, right?
In a small scale, in a laboratory, maybe.
In a laboratory with satellites, with beacon towers, with balloon satellites and balloons, with bouncing things off of other objects in the solar system, like radio waves. If it takes time for light to get from place A to place B, and that speed is constant within known variations of refraction and stuff like that. But
Jose,
if you measure, wait.
I can understand the light.
Let me get
a little bit the light speed. I'm going to let it out. I'm going to just keep talking. I can understand a little bit on the light speed, yeah, and you can maybe measure, it takes time from the planets and all these solid things. Now, on a star, when you tell me it's hundreds of light years,
Jose,
how can we get this demonstrated?
Yes, Jose.
When we haven't
let me make it very clear.
Go ahead.
Let me make it very clear. Let me make it very, very clear. You know, a quarterback throws a ball to a receiver, throws it ahead of the receiver.
Well, what you have just asked is a completely different question to the one that you were asking before that you wanted me to answer. I'm going to keep answering the first question until I get to how you get to the four dimensions and space-time in relation to GPS. So if it takes some time for that signal to get from the satellite to me, I can calculate how far I am from that satellite. I can say I am somewhere on the surface of a sphere, which is 400 kilometers away from that satellite. And then I can take a signal from another satellite and say, well, I'm 300 kilometers away from that satellite. Those two spheres intersect and give me a circle on which I can be the only positions where the distance to one and the other is the same. Then I take the third one, I get 2 points. And then I get a fourth one, and I get 1 point. When I intersect all of those time signals from each of those satellites, I get a single point in space where I can be relative to those. That is what GPS is. That is what triangulation of a position is, right? Now, it all depends on those clocks being very, very, very precise and all ticking at the same rate, like to a very, very fine degree, so that I can calculate that distance. How fine that degree is determines whether the GPS can tell me where I am within a couple of kilometers or a couple of meters or a couple of centimeters, right? Now, there are two effects in general relativity. One is special relativity, which is related to speed. As you move faster, your clock starts ticking slower. So as those satellites are moving around the Earth, they're moving very fast relative to you, so much so that the clocks on those satellites are ticking at a different rate than that very same clock would be if it was next to you, if it was in your hand, right? In general relativity, there is an effect of gravity time dilation where clocks tick faster as you move away from the gravitational field. They tick slower, deeper you are, or the stronger the gravitational field where you are is. So those satellites that are away from the Earth are further away from the depths of that gravitational field. Their clocks tick faster. They tick slower because of their speed. They tick faster because of the gravitational effect. Though when you add those two up, and you need to take both of them and add them up, you still don't get perfectly the same tick that you do. There is still a difference. Those clocks still don't move at the same rate as clocks on Earth would. The relationship between that motion, that backwards motion, that forwards motion, that time dilation and time contraction, that give you that exact amount is perfectly explained 100 years before satellites were even conceived, or 70 years before those satellites were even conceived. It is perfectly described by the general theory of relativity. It is the description of space and time as a fourth-dimensional entity in which space individually and time individually can change depending on your motion and your access to gravity, that gives us the tool to know how to adjust those clocks. That is why we know it works.
Now, Jose? Jose, I'm sure you get it now.
So Montreal, you got to have a basis for something. You have to have somewhere to start to
it's a joke, man, Maxwell. It's a joke.
I understand that. I understand and I agree with you. But you have to have a basis of somewhere to start. To even begin to fathom that you can understand what a fourth dimension is complete bullshit. So they inject space-time into it and call it a fourth dimension. Time is not dimensional. You cannot move forward in time. You cannot move backward in time. You cannot move sideways in time.
Wait, Maxwell.
But they utilize the space-time, utilizes the vectors
Maxwell, I know
time.
You can hear me.
Can I finish my explanation here?
No, because you keep saying something that makes zero sense. 0 cents.
No, you don't, because you don't let me finish.
You have the same spiel, man.
Let me finish, dude.
No, I don't have the same spiel.
Okay, go ahead. I bet I can fucking go word for word with you what you said on Jose's last night, over and over again.
Over and over again, what? What was Einstein's before E equals MC squared? What did Einstein write down before E equals MC squared? What was it?
Oh, continue on, Maxwell. You got something revolutionary to say.
What? You don't know? Barney knows. I'm sure Barney knows.
That sure as hell wasn't what you were saying. So what I'm saying is continue on what you were saying so you can finish, and I can explain how you're wrong. Go ahead.
Okay, I'm just going to make another statement. Einstein's special theory of relativity. Think about that word. Special theory of relativity. Special relativity. Think about that. Think about what he's saying there.
Keep going. Keep going. This
give
is
me a
getting
fucking
good.
break. He didn't even understand what the fuck he was saying. He's got a good explanation of something, but it's only 5% correct.
That's good. That's good.
So they inject this dark matter and dark energy, the other 95% of the universe, to correct the freaking 5% that Einstein was incorrect on.
I couldn't hear either one of you two because Casual Spaceman couldn't stop himself.
Of course, because he's a jackass. He's got to pretend like he understands what anything is. When he actually doesn't know shit.
All I want to do is just ask a question. That's all I want to do. You said you had a problem with the word special. What is the issue with the word special?
Do you even hear his last statement, Casual Spaceman? Because you were so urgent to speak that you were interrupting here. And you didn't hear what he was saying after he said special.
Okay.
Okay, then I'll ask, what's the problem with the word special?
I'm not even going to engage this because you can believe what you want. And I don't give a shit. It's absolutely stupid.
Hang on. Okay, Maxwell.
The problem
I'm
is,
asking you
the
the
problem
question.
is, Sean,
I'm asking the question is, what's the problem with special?
Sean, the problem is, if you were to look into what dimensions are, you would see that you can only presuppose what a fourth dimension is. You cannot understand what a fourth dimension is.
Yeah, because your brain can't construct what a fourth dimension would visually look like. Yes, you're right. But we have an understanding of what it is as in space and time. How do we know?
No,
because it happens every single second
of what you think it is.
Wait,
if they knew what it was, then the other 95% of what's called dark energy and dark matter would make.
What the hell?
Yes.
No, has nothing to do with each other. No. Do you have a start and do you have a beginning? A beginning and an end. You
so
have
what's your
beginning. Hang on, casual. Maxwell, do you have a beginning and an end?
Silence.
I don't know, do we? You can presuppose that we have a beginning.
You weren't born.
Presuppose that we have an end.
So you weren't born. You have to presuppose that you were born, Maxwell? Really? Really, Maxwell?
Wow.
We have to presuppose that you're gonna die? Really?
Okay, so
Maxwell?
now you're talking about the human body, right?
Okay, yep.
So yes, of course there's a beginning and an end.
Thank you. Well, guess what? That span of time, that span is understood in space-time. Am I wrong?
Yeah, you're conflating two different things.
How much? No, I'm not. No, I'm not.
Sean.
Question now.
Yeah, by Maxwell saying there's no fourth dimension, that means he can never use a watch.
I'm not. What?
Yeah.
I'm not saying
Time is the
there's no
fourth
fourth
dimension.
dimension.
Time is the fourth dimension in Einstein's relativity.
Okay, guys. Hang on. Let me make this clear. Hang on, Maxwell, because Barney made this very clear in the beginning. Maybe you didn't hear it. Whether it be, and I thought of it differently, so I'm happy he did say it. It doesn't matter what scale you use it on, as long as we're all on the same page. You're the one, you keep saying that I'm conflating and I'm jumping around, but you're saying that something that doesn't exist can't be proven to you. And I'm giving you a solid example of it, and you're not willing to use it. What does that say, Maxwell?
Time is not dimensional.
What are you talking about? Left, right,
you can't
up, down.
Inject time and call it a fourth dimension. Just because
up, down, left, right. Yeah, up, down, left, right, and then something
doesn't work that way.
Something spatially moving through that would be the time and the duration of it.
I have to agree with Maxwell on this.
All you're doing is defining a point in space and in time, not
congratulations. Wow,
not what Einstein said.
Only a measurement of time concept.
You've now proven to yourself it exists by explaining how you think it's not.
No, it exists in three dimensions. It's not a fourth dimension. It's still three dimensions.
Okay.
So for you to interject into a fourth dimension
is
absolutely bullshit.
Maxwell,
it's fucking ridiculous.
Give me an example of the three dimensions.
Jesus Christ. Everybody knows the three dimensions.
Okay, perfect. Then there's no problem. Can you give them to me?
X, Y, Z. And time is not. Time is non-dimensional.
Okay.
It's all it does is point out what point in time you're in that specific frame of reference.
Stop.
Jesus Christ.
You have given me the three dimensions, correct? Now, if you're showing
time
your
is
life,
non-dimensional.
Oh my God. Really? Are you sure? Because if you add a dimension to that, if you add a event to it, it does.
Okay, so then why can't you move backwards in time? Why can't you move sideways in time?
Time has an arrow.
Yeah.
Exactly. Thank you very much.
Exactly.
That kills the whole fucking argument of whether it's a fourth dimension or not. Because
wait. So because you can't go back in time, it doesn't exist?
That is correct.
Oh, because you think walking backwards is similar to the way time moves.
Oh, I didn't want to
That's
laugh this
good.
stream, but it happened.
Hey, I don't care. Laugh about it.
No, but Maxwell, you think that if you can walk backwards, you should be able to make time go backwards?
Now you're being facetious.
No,
but this is your conclusion.
Wait, hold on 1 second. Maxwell, can you manipulate time?
No, you cannot. You can manipulate the duration of time.
That is manipulating time.
That is manipulating time.
Yeah, that's manipulating time. The duration between events would be manipulating it. How long you wait this time? How long you wait the next time? How long you wait the time before that?
So now you can manipulate time. So you can
Hold
create
on, Maxwell.
time. You can create time.
Actually, you can. Okay, so the way I can describe it, probably the best way. Well, Thanksgiving's coming up, so you have a turkey, a frozen turkey. You can either defrost it in the fridge or you can defrost it on the counter. That's manipulating time.
No, it's not. Because, okay, here, let me use my example. You can crack an egg on a pan and fry it, but you can't fucking take the egg out of the pan and put it back into its original state. Can you?
You've already changed the
That's not what relativity is talking about.
Oh, yeah? Just do a little research and look up Arrow of Time, and there's a bunch of other things you can look
Which
up.
can refreeze
Entropy
explains that very well.
But there are limits to our movement in space as well, right? You can sit in a car and go at 60 miles an hour east, but you can't sit in a car and go at 60 miles an hour down. Because there's something in your way. There are limits to motion through space as well. Does that prove that space does not exist and that space is not a dimension?
No, but it doesn't prove space and time
It's still
are
only
combined
three
together.
dimension. It's still only 3 dimensions. Regardless of how you look at it, it's nothing more than 3 dimensions. And by injecting the time at which you're at the specific freaking point in your dimension does not fucking create another dimension.
I agree with you on a very human base down level, intuitive level. I agree with you. Yes, I live in 3-dimensional space and I understand space is 3-dimensional, right? The thing is that doesn't work. That doesn't work for explaining the universe. That doesn't work for things that we know that happen and that things that we experience and describe, right? It doesn't work. You cannot describe them. What you're saying
Neither does
is
space-time. Barney, space-time doesn't explain it either. It doesn't
yes,
work.
It does.
It's
yes,
95.
It does.
It's 95% wrong.
It is 95% wrong.
Unquestionable what he just said, Barney.
It is
then prove that it's
absolutely questionable.
Prove that it's 95%.
You're talking about dark matter and dark energy. Yes, there are things. Yes, there are things that we do not know about it. That is not
only are they things,
and we only know.
You don't know 95% of those things.
Yeah, agreed. No. Agreed. I will agree with that completely. We do not know 95% of it, but we do know the 5%, right? Yeah. And what you're saying is that 5% is not there, and we know it. We know it, and it is necessarily so. It is proven to be so. It cannot be otherwise. Even when whatever you find out about the 95% will add to our knowledge, but the 5% that we do know, we know, and the 1% we knew, right? It describes reality. It describes reality.
And the proposed theory, the proposed theory of the understanding is based on that 5%.
You guys are
get
saying
angry when somebody questions that 5%.
You're saying that 95% is incorrect. No, you're saying 95% is incorrect when in reality, what you're meaning to say is 5% is understood.
Yes, 95 is unknown. 95 is not understood. But the 5% that we do know them. They work exactly like that consistently, and we can make accurate predictions upon them. Where the statement of there are only 3 dimensions of space, and time is something completely different. That space is fixed background of 3 dimensions, Euclidean, at right angles to each other. That is necessarily wrong. That does not describe the reality we live in. It doesn't work for describing reality we live in, right? It doesn't work here on Earth right now. It just doesn't work. So if you're saying time is this thing that I feel it is, and space is this thing that I feel it is, you are necessarily wrong, because it doesn't work. You cannot describe reality that way.
Can I ask a question from Montreal and no subscription necessary?
Yeah, one second. But right before you do that, I wanted to say it's the same thing. Again, I made this clear to Maxwell. If we're talking on the same scales, then we can talk. But once we start changing the scale of which we're talking space-time, that's where the problem will start. And you jumped instantly to entropy. We weren't talking entropy. Second.
You're talking about scale? You're talking about like the speed of light that it have been tested
the scale,
and created in laboratories?
The scale as
and
in...
we don't know anything
No,
the
scale as in... Jose! The scale as in
I was
the
trying
time.
to finish my statement, bro. But
Yeah, no, but
me.
I was in the middle of talking. You weren't even talking, because Zane then was asking if he could ask something. I stopped him. You weren't talking. We're talking scale as in the time on our watches. The scale as in how the orbits of a satellite. We're talking. If you want to talk to entropy, fine, we can talk that. But that's the arrow of time. But we have to be talking on the same scale. That's number one. Number two, you were given plenty of examples of it. Again, that fourth dimension you keep saying isn't real. It's real because you keep saying a point in time.
It's not real. It's not dimensional.
Okay.
And it's absolutely stupid that people think
that's your opinion.
Time
that's your
is dimensional.
That's your opinion, not your understanding.
Can they and them ask his question?
Yep.
Right. So, Montreal and Michael, I agree with you. We don't know 95% of what's out there, right?
Wrong.
But you're saying the other 5% is wrong.
No.
So
they're saying 95% is wrong. Only 5% is known. That's all. That's what they're saying. They're saying that 95% of it is wrong.
Yep.
Yeah, because Einstein's special theory of relativity and cosmology does not work. It only works on a 5% scale. The other 95% of dark
you're wrong.
And dark energy that's injected.
You don't get it.
They
no,
know
Maxwell. Again, let me say this again so you understand it. I'll say it again. Barney said it, and I've said it twice.
You need to fucking do some research on.
This is exactly what it is. Because you don't understand how it's even phrased to be saying it. It's not 95% is incorrect.
I completely understand how it works.
It's of the 100%. Stop, casual. Stop, casual. Stop. Cop. You're saying 95% is wrong, whereas in reality, it's unknown.
What's fucking ridiculous is you people sitting there spewing this shit.
95%. Let me say this again. Let me say this again, Maxwell. Let me say it again, Maxwell. 95% is unknown. What part of unknown don't you understand and make it seem as if it's wrong? What part of that?
He's gone.
Exactly.
Oh, well. Okay, so people understand. It's very clear. Hang on. I want to make this very clear. Of this 100% that we're looking at of the known, 95 is unknown. We have an understanding of it. 5% we understand. The 95% we don't understand isn't wrong because we don't understand it enough to tell you about it.
What he's basically saying,
I'd like to.
He thinks the 95% knows about the 95%, therefore it's wrong. So he's talking bullshit, is what he's talking about.
I'd like to chuck something out here.
He's ascribing the 95% by mass, literally, right?
Yeah. Exactly.
By how many of the things that are known exist and how many of the things that are unknown exist, right? All of those 95% could be explained potentially with one equation if we come up on it, right? By another Einstein having a simple idea of something that we have assumed for thousands of years, which just doesn't work. But that still, all of that still does not give you a carte blanche to say, therefore, the 5% that we do know is wrong. And that's like, I don't mind him saying 95% of what we don't know. But how do you get from we don't know 95%, therefore we don't know the 5% that we know? We know them. They work. They're tested. They give predictions. They explain things. They explain things that we have never seen before they were brought about. It's being confirmed to this day on a daily, weekly, monthly basis by new discoveries that weren't even conceived back then.
That's exactly what I was saying earlier on.
And this was about GPS.
Understand what the 95% is.
I found the problem.
Therefore, they don't know what it is. I don't understand it. Therefore, it is wrong, or it does not exist, or it's bullshit. Because that's what they're just going to keep spouting every single time. I don't understand it. Therefore, it's wrong. That's the only.
I found.
Wouldn't you tell us your vision of the truth, Casual? Because you've been talking
Casual
about
don't understand it, but
wouldn't you tell us?
It's right, right?
You said right from the word beginning is this is all bullshit, but you've got no explanation as to why it's bullshit. That's what I'm trying to say.
That's my opinion. I'm asking your opinion now. We all know my opinion. Tell us your.
No.
Tell us your genius.
That's perfect. I like that he said that. Hang on. Casual. I like that he said that. I like that he said his opinion this time. It's fine to be your opinion, but don't make it your understanding unless you understand it.
Exactly.
But I can throw that right back at you, Shawn.
Absolutely, you can. 100%. But I'm also not telling you your alternative is wrong because you're not giving it an alternative.
Exactly. That's what I'm talking about. No alternative whatsoever.
This 95% thing, I know where it came from.
I really have to comment on scale. There was a comment earlier about the speed of light, right? What I understand a little bit, it would have taken me 30 seconds, but I have to process what I want to say. So it's going to take me 1 minute, please.
No problem.
The speed of light is being determined in small-scale laboratories doing very elaborated equations. So when we want to talk speed of light and the bouncing of light in them, Unpaid shills is hot miking big time. Speed of light, when we want to maybe measure the speed of light to the sun is 8 minutes roughly or whatever. Now on planets it's going to take a little longer. When you tell me the closest star is, I don't want to throw a number, but it's a big number, 100 years, light years, for example. How can we determine these things when we should be using only objects and things that we can like measure for real? I'm giving you a lot of slack. I'm giving you up to the planets and the sun, which is very far away. How can you tell me 100 light years, 500 light years, 1,000 light years? How can you determine this when the light year have been determined only mathematically in a small scale?
Well, actually,
because we can actually.
I don't know if it makes any sense.
Hang on, casual. Real quick. Actually, Jose, you can measure the speed of light at home.
Okay. My question is, how can we know how far a star is on light years when I just don't understand how
because a speed of light is measured on the basis of the speed of a light year is what you're talking about, can be measured based on the speed of light. That's what it is.
I could answer him that question.
So if
how far
quick.
how far light can travel in a year. That's basically what it is.
If a light can be bounced, let's say of the sun, and it's going to take 8 minutes for the light at the fastest speed to bounce back to the sun, right? 8 minutes. Yeah, we can wait 8 minutes. How am I going to wait 100 years to measure the distance to a star?
You don't need 100.
You cannot directly. What you can is look for consistency, right? The nearest star to us is 4 light years away. That is so near that you can measure the parallax very accurately. Like that is within the scope of like everyday measurements. You can do it with an amateur telescope. Right? You still need a telescope, but you can do it with an amateur telescope. You can do that up to a certain distance. And that parallax, that simple triangulation of my position was here and my position was here when I took the other measurement, that is the basis of my triangle. I saw it at this angle and I saw it at this angle, and therefore I know everything about that triangle, including the distance to that star.
The parallax.
Right?
How do I add light to it now?
That's a good question, though, Jose. The whole question is a really good question. Well done, man.
How do we know that light traveled to us at the speed of light?
How do we know how long it takes that light to reach us?
Oh, that's simple deduction. That's based on what we know light to be and how it propagates. Its speed is necessarily that speed, right? We cannot measure the speed of light from that star, if that's what you're asking. We cannot.
Yeah, I'm not gonna try to ask it again because it's gonna get more convoluted. But I didn't have the answer to my question.
I think what he's talking about.
The direct and sincere answer to your question is no. We cannot measure that light took 4 years to travel to us, right?
Thank you.
We would use this, the red.
It's all guesswork and triangulation, Jose.
No, it's a shift.
It's not guesswork. No, it's not. No, it's not.
So you're saying that the color of a star doesn't determine its distance?
Yeah, that's what I'm saying. It's all guesswork.
So a color of a star doesn't
light-year stars that they see far away.
So the color of a star does not determine its distance. Because I'm not you, Montreal. Someone else was saying it's not. That's not what it was.
We could measure the distance over 100 speed of light over 100 meters easily.
It's my understanding, gentlemen, the way they measure, to answer Jose's question.
It doesn't make a difference the distance. We can measure the speed of light over 100 meters.
Okay.
This is literally the objection of we don't know that a trillion exists because we can count to 10 and we can count to 100, but nobody can count to a trillion.
Yeah.
That's literally the objection you're giving.
Some people in the chat is telling, somebody's trying to understand this whole concept that take many years and hundreds of hours of dedication and a lot of research and doing and testing. I understand that. We want to learn it all in a boom, compacted in 2 hours. I understand it's not, and it's boggling my mind and many other people. I apologize, Barney, if you thought I was trolling. I'm really not. I got legit questions. It's just the way the interaction is going. It's a little heated, you know.
The confusion comes, if you don't mind me just saying this, I'm just going to say it calmly. I'm not going to get excited as I've done before. The confusion lies between what a light year is and actually measuring the speed of light. Basically the measurement of the speed of light is just purely a measurement of distance. Okay, sorry, a light, beg your pardon, so I correct myself. A light year is just a measurement of distance. Okay, the speed of light is basically just a measurement of how fast it is. They're two different things. So once we know what the speed of light is, we can calculate how far the speed of light will go in a year. That's all that is, because we often talk about light seconds, like minutes, like days, like months, even if you want to. It's just purely just a measurement. So once we know what the speed of light is, we can easily calculate what a light year consists of or what distance that is.
I just want to say we were really good flat earthers today, Montreal, Maxwell, and myself. Thank you.
Can I get a second, Sean G?
Yes, we were.
You were.
Go ahead, Jill.
It wasn't Shills, that was me.
Oh, my bad. I apologize.
This all comes back to understanding and a frame of reference. Most people know the understandings of how a basic engine works, but if I tried to explain to them how cam phasing and everything else works on a modern engine, they would be completely lost. So unless we can find a middle ground at some point in this that we can all understand and agree upon to build the rest of it on, it gets kind of irrelevant, because if you don't understand the basics and have something to build from, you can't go forward or backwards.
And I think that'd be the scale of it as well.
But then you can't come into a debate about cars and just say that the timings are bullshit. That's what you can't do, which is what one particular or a couple have actually just done just a moment ago.
You have nothing to build on. The difference is the camshaft and the engine and the crankshaft are absolutely observable. Yes, you can't with that baseball.
Yes, and these and general relativity is absolutely observable.
I measure the speed of light is observable, completely 100%.
Yeah, you can pretend because you've measured it, right?
No,
you've measured
no,
it.
no, it's not pretending. No.
Right, you haven't measured it. That's the point. You haven't measured it. You're full of shit.
Red
Stop
October?
it. Get the fuck
Red
out of
October?
here.
Stop it.
Stop it with
Stop
these
it.
lies. You guys got to stop
Stop
lying
it.
and actually do things in reality. Don't tell me
Stop
about
it.
speed of light, dumbass.
Video on my channel.
Hold on.
You haven't measured shit.
I have a question.
Shut your mouth, dumbass. Yeah, one at a time.
Can I ask my
Hey,
question before we go on
can we
further?
stop talking over each other, please?
Seriously. Yeah. Hey, Red October. I got a question. Hold on, Spaceman. Red October, I got a question.
Ask me a question, then let him talk.
Hold on. I've got a question. Have you seen God?
That was so scary.
Yeah, somebody's got a hot mic. I don't know what you guys are doing.
Yeah, I didn't think so. Anyways.
Yeah, anybody have a relevant question to the topic, or do you want to pretend you've measured the speed of light, dumbass?
Really?
You gotta be fucking kidding me. Are you fucking
Breathe
serious?
it out.
Are you that fucking stupid? You want to tell me you measured the speed of light, bitch?
Relax.
Slap the fucking stupid out of your face, you retard. How dare you?
Because it will get worse.
Sean,
relax, man.
I think
retard.
I think some moderation is required in here.
You're right.
Yeah, get some moderation here and stop preaching child abuse, and you're gonna fucking promote ridiculous pseudoscience religion.
Everybody, please stop and start acting like adults.
Retards.
Red October, there is no point in going. No.
Oh God.
Red October, I haven't said anything all night, and it is now getting to the point where people talking over each other is just ridiculous. Can we please behave like civilized people and actually treat each other with respect?
No, it wasn't necessary. Yeah,
it's been taken care of.
I think the next step we need to take is to try and get on the same page as a starting block. Once we're on that same page as a starting block, once we can find a point to agree upon, we can build on that.
Well, it's clear that the guy that came and rocked to Red October was actually saying just a moment ago he's gone. So
I want to say
reason why he was there was just a troll. So that's pretty obvious.
I want to say that was MG42 pillbox. It sounded like him. I'm not sure. It just sounded like him. He's like flutter data.
Yes, it was him.
He was just a troll. He was just a troll.
Anyway, just to bring us back on track, I have found where this 95% bullshit came from.
Only now?
No, hang on. It came from an article in the New York Times in 1982. It doesn't prove anything wrong, but what it says is, but this week physicists from University of Arizona announced findings that prove with 95% certainty that Einstein's theory of general relativity is not correct.
No, you got it wrong. What he was talking about is dark matter and dark energy consisting the 95% of matter in the universe, of gravitational effects in the universe. Right?
Oh, so he understands dark matter, does he?
No, he says that nobody understands it, and it proves Einstein's theory wrong because it proves that it is incomplete.
The thing is that someone made the point earlier, which I was trying to make as well, that this dark matter and the dark energy, separate by the way, dark matter may be one single thing that we don't yet understand, and dark energy may be one single thing we don't yet understand. And once we find the key to each of those two problems, we've got it. Then what are people going to say?
Yes, for right now, you're basing your own understanding on a lot of the behavior and the physics based on this 5% that we understand now. When more is discovered and tested, on that 95%, then things can be altered, added, or superseded. But for right now, you got a theory that works.
Of course. That's how
yes, but
science works.
The things that we know now will not go away in the same way that Newton's equations didn't go away with Einstein. They still describe motions at, like, right? There might be a theory, a greater theory of general relativity, a quantum theory of general relativity, a quantum theory of gravity, grand unifying theory, right? The theory of everything. All of these are possible theories that we might get to, but all of them
string theory? Maybe also the string theory?
No, not string theory. Possibly.
Let's just.
No, wait. All of these, whichever one works, will have to incorporate that which we already know. In the same way that Einstein, like if Einstein's general theory of relativity said that Newton's equations flat out didn't work when we know they worked, then we would say that Einstein is wrong and he's deluded, right? His theory superseded Newton, but it didn't erase Newton. Newton is just as valid as he was then. In the same sense, whatever comes after, whatever comes on that higher level of theory, will have to include what we know now in general relativity. You will never get away from that space-time interval concept. It is necessary. It is a logic. It's not merely mathematically necessary. It is logically necessary. It must be so.
Okay. If it's true or not. String theory, Michio Kaku is one of the head people working on it and building this theory. You tell me if I'm right or wrong. There's a lot of scientists looking into it and elaborating it and trying to refine it. When they get it nailed down to the ground and they say this is how string theory works, is it going to be accepted broadly by everybody?
If it encompasses okay, never mind.
Go ahead.
Okay, I was going to say if it encompasses the knowledge that we currently have, builds upon that, explains more, and provides a better predictive model, then it would most likely be embraced by this greater scientific community. If not, it'll be thrown out. We'll start looking for something else.
So from my understanding of string theory, the problem with string theory is not that it cannot explain the universe. It can. It is already past the point where it can explain this universe. The only problem is it explains too many things. It explains so many different universes, like infinitely many universes, only one of which is ours. And there is no way to constrain it to ours. What they are doing in the field, they're trying to find ways to constrain it so that you can say, when talking about our universe, this should happen. That is what string theory currently doesn't have. Therefore, string theory isn't a scientific theory. It is not even a hypothesis yet. It is a line of research. It is something that shows promise that it might provide a hypothesis. And then that hypothesis might be tested, right? But as of now, it is just a mathematical, philosophical construct that has a lot of potential, but isn't finished, isn't able to give predictions, isn't able to be constrained to what we can observe. You cannot get predictions out of it. You can explain things that you see through it, but you cannot give predictions through it.
Do you think somebody might get a little confused and maybe take the wrong path if they are studying really high, and they get a big, somebody, let's say you get a big understanding on theory of relativity and the space-time, right? And if that person, they said, I want to take a look at this string theory and dedicate many years to look into it. And do you think they can be persuaded and jump from the theory of relativity to say, oh no, I'm gonna grab into this string theory because it explains more and better, and they will kick the theory of relativity out? They say, yeah, works better. Now, what's the difference between both of the terms they say the same. One is the theory of relativity. The other one is the string theory. How can I rephrase it in a different way to know which one is scientific and which one not? One is one word and theory. You know.
Okay, that's why
ambiguity. The thing that you are looking for is ambiguity. If it explains too few things and doesn't explain anything, then you cannot use it. If it explains too many things, if it explains why things fall down, that's great. But if it also explains why things fall up and why things fall sideways and why things fall in hexagonal spirals, then it's useless. It's a mathematical tool, right? There are more venues of this research. String theory is the most well-known amongst laymen, but there is a lot of different ways in which quantum physics and general relativity are trying to be combined. You have loop quantum gravity, you have supersymmetry, you have, I don't know, there's a whole bunch of them which are more or less well understood and well researched and well funded.
How can I differentiate which theory is the one?
Wait, is it possible? Is it possible for somebody to get convinced on the level of belief? Yes, there are many scientists and many people who believe that the string theory is or will provide the correct answer. And as much as you research it, you might get convinced that it is the right answer and then argue for it. But as long as there is ambiguity in it, as long as you cannot show that it is necessarily so, it will only be speculation.
How can I determine which one? How can I determine which theory is the scientific theory? Is it only based on papers and scientific consensus?
Here's the problem, Jose, and this is why I'm such an ass about this. People are using the word theory incorrectly. Okay, string theory is not a theory; it's a string conjecture, and that's why
I've always heard it as a string theory.
And
it's called a string theory. It's called string theory. It is not a scientific theory yet.
So what the difference on a theory and a
about
scientific theory? Is it citations, papers, and scientific consensus?
No.
What is the difference between scientific theory and theory?
So, the components of a theory are theorems. The theorems are hypotheses which have been confirmed and have not been disproven. A hypothesis is speculation. It is a guess which is such that it gives an unambiguous prediction. If this theory holds, then this must necessarily be true. That thing must, at least in principle, be testable. And the more of such predictions it gives, the stronger it is. General relativity gave hundreds of predictions that were not seen before that, and were all confirmed one after another to this day, right? And we're still confirming them. That part of the scientific process where you verify your explanation by making an unknown prediction, testing it and finding it to be true, and then testing it again and right? And going deeper, refining your theory based on experiment, based on observation in the real world is what disambiguates an accepted theory, a real theory, a scientific theory from mere speculation. String theory literally does not yet possess the potency to even give a prediction, to even say, if this, then this will happen. Right?
It's not even a theory, Barney.
One last point, guys. I got one last point. Maybe I can explain it a little better now, right? Now, I say, I want to study, I want to learn about some of the scientific theories. And I Google and I go to the archives, I say, list me 10 theories. that I can research, right? And it gave me a list of 10 theories: the unicorn theory, the theory of relativity, string theory, the theory of the farting gnomes, the theory of this and that. How, me not knowing any of it, which one I'm going to study as the real scientific theory? How can I determine that of a list? To see if I can get to the answer of my question.
Citations. This is
amen.
No,
so scientific consensus,
no.
right?
No, let me
no.
All right, I'll just go ahead.
Logic, reason.
Well,
like,
I don't know.
You can study. You cannot determine that without studying the theory. You cannot determine whether a theory is valid without sitting down and seeing what it says, right? You have to learn. You have to get to the information of what it is before you can say whether it makes sense or it doesn't make sense, whether it's valid or it's invalid.
10 years of my life researching and studying a theory that is.
Then don't do science.
Which theory I'm going to study.
Then don't do science. There are people who do this for a living, specifically this.
And I want to be an expert on a scientific theory. I just got a list of 10 theories. They say, choose which one is the scientific theory. How am I going to determine that? Do I have to ask the higher scientists? So I say, oh, this is the consensus say, this is what the body of science says. This is the theory that you have to study. This is a scientific theory, or it's not how it works. That's what I wanted to know, to see if I get an answer to my question.
Does it describe the problem? Does it give you solutions to the problem? Does it create predictions? Are those predictions testable? Have they been tested and did it hold up? Right? Those are the criteria.
And a theory, yeah.
I don't believe that's correct.
Why is string theory not?
I think
Why
you
is
have to have a hypothesis first, then put it through a scientific test, then you have the theory, if I'm not mistaken, sir.
You don't always need a
hypothesis. I'm trying to find the
hypothesis.
answer to my question in one of my streams. Maybe somebody will give me a concise answer.
I'm trying to do exactly
or
that.
talking over me.
I'm trying to actually give you a concise answer.
I just want to correct Barney.
Oh, fuck.
Barney said that if you misunderstood it, what I meant, what I did not mean, if I said it, I didn't mean it that way, that Einstein was 95% wrong. If that's the way if I said that, that's not the way I meant it. What I meant was Einstein's
that he was
special
100%
theory,
wrong.
No, that he was 95% incomplete. Okay, I'm calling bullshit. I'm calling bullshit on the fourth dimension. That's wrong.
That is necessary in what Einstein discovered. That is unavoidable. That is in the 5% that we do know, right?
Okay, so now I got that.
There might be things.
Let's keep it going with string theory, Barney, because I'm interested in this. I would like to know. Can you observe an atom?
Yes.
You can visually observe a single atom.
Yes. We've done it with hydrogen.
With what?
Hydrogen.
With
electron microscope.
Yeah.
Huh. Last I checked, you couldn't visually observe an atom.
They did.
The human race, the scientific community, we have made cartoons with atoms, moving one atom at a time and taking pictures of it.
Well, I know they've made
literally a stick figure going, "Hi, look, we can move single atoms now."
So what is it they can't visual? What is it they can't visually observe? Is it an electron, a proton, a neutron?
You cannot directly visually observe anything below an atom. Well, so visually meaning through visible light, there are some new methods where you can just barely see an atom visually through optical light, but it's very convoluted. Anything much smaller than an electron, no, you can't visually see an electron as a particle, but you can see its interactions visually, right? When you watch those CRT TV screens, the flashes of lights are literally electrons hitting So you can see an interaction.
Right.
You can see
So I get
evidence of
that.
its existing.
So string
Right.
theory, what has been visually tested?
Nothing.
It's all
Nothing.
been
String.
it's all mathematical.
Yeah, string theory is not a theory. String theory is not a scientific theory. It has made no predictions. There is nothing to test.
It's a competing.
Finally, we can agree on something, Barney.
Right? You need to be able to say if A then B, or when A then B, or at least say B to be able to test it. String theory cannot say any of those things about anything.
And not to mention, isn't string theory also trying to speak upon beyond general relativity? It's not trying to replace it. Again, it's one of those things where it's trying to answer.
Well, it's trying to make a connection. That's all.
Yeah, if they find a way to constrain string theory in such a way that it describes our universe and our universe alone, in such a way that it can make measurable predictions, at least in principle, it would still have to obey general relativity. Because general relativity has already been observed and confirmed.
And that would go for the same situation of a quote-unquote alternative to gravity. It would have to encompass everything we know about gravity and then some.
Yes.
I would like to hear Unpaid shill for like 10 seconds.
Go ahead.
Okay, Jose, what was your question again?
How to determine which one is a scientific theory of a list of theories?
Okay, there are two unfortunate definitions of theory. There's the colloquial definition where people say, "Oh, it's just a theory," meaning, "Oh, it's just a wild guess," and that's why I'm always beating on that drum. It's not just a theory. It's a conjecture. It's a hypothesis. It's a guess. A theory is actually, it provides predictive power. It is accepted by the scientific community as fact. It is demonstrated to be, for all intents and purposes, fact. So if somebody says, I've got a theory of the world being created by unicorns farting, well, you've got to go in and look at these things and say, does this jive with what I already know and what the scientific community already knows?
And quite often, if I'm not mistaken as well, theories can be measurable. Not always, but sometimes.
So is it mostly based on scientific consensus? If I want to know, I want to study this theory, I need to look up and ask somebody smarter and look into the scientific papers. This is a scientific theory.
They're usually the ones that have already done tests themselves to verify what this person's saying or a theory is saying.
I haven't get an answer to my question yet.
It's a big.
Well, here it is. No, here's what it is. Jose, you would have to have an understanding of the theories of the scientific of general relativity, then to understand what these other ones are even trying to say. That's the reality of it.
Yeah.
So how do I know that the theory of relativity is a scientific theory? Because of the consensus and the body of science tells me this is a scientific theory. How do I determine which one is the real scientific theory of a list of theories?
Because general relativity's predictions have all been predicted and verified. That's how we know.
I think I might be able to give it a bit of clarity. Please correct me if I'm wrong, Jose, but I think you do understand the difference between what is a hypothesis and a theory. What Jose is asking is that how do we know what a theory is and what is a hypothesis? In other words, what do we? Is that what you're saying, Jose, or is that what you're saying?
I Google a list of theories, and in between those is the theory of relativity, the theory of string theory, and other many theories. And then I want to know. I want to study one deeper.
Those are.
Go ahead. Finish my question.
No. Because I know exactly what you're saying now. Okay. Because one is a scientific theory, general relativity, and the other ones are theories. They're two different things. You got to remember that.
How to determine which one is which one? That's my question.
Perfect. A scientific theory has been been ran through all the tests. It's been ran through everything. It's been able to make predictions. These other theories haven't been able to pass any of the tests, haven't been able to predict anything for us to verify it. That's how we know, because they haven't verified.
Without knowing?
You have to do your own research. 100%. That's research. Research.
Oh, what am I going to research in the scientific papers? Scientific community,
sure, everything.
That tells me this
you
is
can't
a
do
scientific
it.
theory. That's
you
what
try,
I want to know.
fine.
And I'm trying to give you the answer, but you don't want to accept that.
No, I'm accepting it 100%. You need to then pick one and hope it works then, Jose. But regardless, you have to have an understanding of each of the theories and the scientific theories that in which they all have to adhere. Then you can understand what those ones say.
So correct me if I'm wrong. Now, I want to study the string theory, and I call 100 scientists, and I go to all the papers, and they will tell me this is a scientific theory, or this is just a theory in the works. And if I ask the theory of relativity,
every one of them.
Who do I ask to say?
They'll all say
to spend 20 years on John, come on, man.
They'll all say their theories, not scientific theories. But I'm trying to. But you're conflating
it. Exactly. That's what I want to know.
But
which one should I research?
That's why it's research. That's why it's research. You don't know what you will find.
I learn? Who do I ask? Which one is scientific theory? That's all I want to know, and I haven't given the answer.
Nobody can tell you what we're going to discover in 10 years. Nobody's going to tell you what you're going to discover tomorrow. If you're going into science,
this is a scientific theory. This is what's up. This is the truth.
If you're going to study science, you're going in it to discover things which haven't been discovered before, right? You are in it to find your own hypothesis and find your own theories and find out if they're right or wrong. And you want to prove yourself wrong as much as you want to prove yourself right, because you want to know the truth.
And also, Jose,
it all starts.
None of those other theories, not one of those theories will ever tell you they are scientific theories. That's how you know.
How do I know that? Who will tell me if it's scientific or
read
not?
Them. If you read into them, they'll tell you in their thesis. It is not a scientific theory, or it's just a theory. It's just a hypothesis.
Jose,
they will tell you.
Jose, science is all about proving something wrong or right. It's not about actually work with the general consensus. Therefore,
it's trying to prove it wrong. It's not. It's not trying to casual. It's not trying to prove anything right.
Go ahead.
It's never trying to prove anything right. It's constantly trying to prove itself wrong.
Sorry, okay, yeah, quite right. Yeah, sorry, you're quite correct. Sorry, proving yourself wrong. Yeah, quite correct. Sorry.
The thing is, I believe it all starts with people need to quit using the term theory incorrectly. I guess that's what it all boils down to.
100%
There's a big difference between a hypothesis and a theory. Theory is not necessarily just guesswork.
You can't prescribe language that way.
What do you mean?
Gentlemen, sorry to interrupt, Barney. I have to say good night. I have to go. Sean G, thank you very much for the opportunity.
Yes, sir. Thank you for being
on. Good
on.
night, everybody. This is a nice, very nice topic. Jose, you're killing it, man. Keep it up.
Later, Montreal.
Good night, guys.
Later.
I'll keep listening. I'll stay on mute.
You know what I'm saying, though, Jose, right?
No, you don't have to stay on mute.
I got a sparring question.
Yeah, go ahead, Maxwell.
It's so like, okay, so a hypothesis. I mean, I'm not educated with the terms and how they're used, but I'm assuming that a hypothesis is something that you say, if I do this is what I think will happen, and then you test that, and then if it is,
it's more of
is that right?
This is why I think I observed something.
You can define it much more loosely. So a hypothesis is just a speculation, right? Something that you guess. It doesn't have to be scientific. If you guess that the cause of something is green elves, that's a hypothesis, right? That's speculation. Now, if you find a way to constrain your speculation in such a way that there are things necessarily follow from it by logical reasoning, by deduction, if my speculation is correct, then this too must also be correct. And if that is unambiguous, and if it is measurable, that's a form of a hypothesis, right? It's malformed, it's not mathematical, it's not well described, it's not well constrained. That's why we wouldn't call it a scientific hypothesis, but it's still a hypothesis, right? As long as you have some inputs and an expected outcome. When that outcome doesn't happen, you know that your hypothesis was wrong on some level, on some basis. Therefore, you need to either adapt your hypothesis, change it, take something more into account, or agree that you don't understand it, right? If you want to understand
So let me get my point before I forget. It almost makes it sound like you're molding your experiment to match your hypothesis. It doesn't make any sense to me.
It doesn't make any sense because I'm assuming that you're neglecting the point of ambiguity, right? The basis of science is not mathematics. Mathematics is just a language in which it is expressed because the language itself is unambiguous. But the basis of science is logic. It is reasoning. It is what necessarily must follow versus what possibly could follow, right? There are things which necessarily must follow. If you follow the chain of things that necessarily must follow, you will only be discovering new things that are true. You will never discover a new thing which is false, which is incorrect, because that incorrect thing will automatically tell itself apart by
I just want to say goodbye, but actually I want to say, since you've come back, subscription necessary, your line of question has been much, much better. So thanks for that. Appreciate it. So thanks very much, guys. Goodbye. Thanks, Shawn. Appreciate it.
Right. And there are many things which are kind of assumed about science which aren't true. That science says something about the noise. It doesn't. Right? There are things which you can say necessarily about the signal, which tell you nothing about the noise. So when we're talking about dark matter, a lot of people wrongfully assume that this is therefore necessarily some kind of a particle or some kind of substance. Those are speculations which are not hypotheses yet. Some of them are hypotheses and are being tested right now. But what we are working with is the things which can be known, which can be tested. Anything that cannot be tested is simply not within the purview. That is the noise, right? That is the thing that is not covered by the hypothesis. That is not even that the hypothesis is not even attempting to explain. It is if you want to shoehorn God in there, fine. Then that's God. Right.
Yeah, I'd just rather not even talk about it. I mean, it's kind of pointless about something that I mean, even the mainstream scientists in the world can't even begin to understand or at anywhere close to understanding.
I know, but so they're not close to having a definite answer, or none of the answers that we've come up with have been proven yet. Some of them have been disproven. Some of them are questionable. Some of them cannot be tested. But we are testing the ones that can be tested, like the hypothesis about what dark matter is that makes sense given our existing knowledge and can be added in without violating known laws and known explanations of the universe. Those are being tested right now, and they will either give a result or not. And if they give a result, it will either disprove the hypothesis, in which case, yay, we now know more. We know it's not this thing. Or It won't. In which case, that's a viable theory. That's a viable hypothesis.
So what's this? I don't know. You know, Einstein wrote his E equals mc squared. First, he wrote it as mass equals
he didn't write it as E equals mc squared.
Right.
Mass equals energy over the speed of light squared. But it's
so why is there such a controversy on mass? I mean, sure, it's explained, and it's explained very well right now, but that it doesn't explain. You know, once you get into quantum mechanics and on the large scale like cosmology, it just doesn't work.
What doesn't work?
The mass equation.
Equals, you have a molecule which is consisted of two atoms of hydrogen. That molecule is in a lower energy state. It has lower potential energy. Therefore, that molecule, which consists of those two things, weighs less than those two things.
Yeah, but that works in a closed system. You know, like if you have a closed box with a light, you know, and the light is turned on, and that's draining the energy from that creates the light. The light doesn't escape the box, so the mass is not going to change. But if the light can escape the box, the mass will change of the box.
Yes.
So that then you get into entropy, and that it says that shouldn't happen. You know,
why?
Oh, I don't know. This is getting too deep for me to.
Yeah, it'll mess with your mind. It will.
I got a question. Who have been the best flat earther today? Montreal, Maxwell,
Jose. Jose has been the best flat earther today.
Thank you. I think I started all this shit. I'm sorry.
Well, you have been the best flat earther as far as me as a glober am concerned. As far as flat earthers, I'm guessing that the Red October has been the best.
Yeah, he stirred some real good shit up in here. I left the room for like 3 seconds. I have my headphones on, and all of a sudden I just hear, ah! I'm like, oh, what the hell?
Yeah, I'm completely done with him.
Shanji,
yeah, that was a little uncalled for.
I've posted a link to A Boy and His Atom, which is that cartoon made with atoms that I've talked about from IBM. If you want to share it.
Where did you share it at?
In the inside chat. It's a couple of. It was 20 minutes ago when we were talking about it, but
yeah, I found it. Yeah. I think we'll do that.
So do you think that the breakthrough will come in science when they figure out a way to observe things smaller than an atom?
Well, what do you mean observe? Watch them, image them?
Physically observe, like with an electron microscope, if they were to come up with some
that's
new
completely irrelevant
that utilizes. Huh?
That's completely irrelevant. Like we can, as far as measurements go, we can measure and observe things way, way, way below that level.
Well, I know. So you can observe stuff smaller than an atom?
Yes. The LIGO detector's accuracy is something like 10th of.
I think Barney fell off. But until he comes back, we'll watch this real quick.
I appear to have dropped out. What I was saying was the accuracy of our detections and stuff like that is way below that limit of an atom. LIGO detector is something like a tenth of a proton in accuracy, that tenth of a width of a proton. We can measure things way more accurately than an atom. What you're asking for is imaging, and imaging. Well, we have limits in imaging, but it's not that relevant. We can detect these things. We can measure them.
Oh yeah, because they have a mathematical representation of what's going on. I mean, so you're
Maxwell, right. I appreciate that you want to be visually able to see these, but if we go back in time, we weren't able to see the constituents of cells in the human body. Had an understanding that there was something inside it before we could physically see it.
okay.
Yeah.
So what do you think by seeing it will? Do you think it will give us a better understanding of something that we're missing, or?
I mean, you have to visualize something, right? Whether it be a mathematical representation of what you're seeing, like they use with the Hadron Collider or the LIGO, or if you visually visualize a graphic representation of it, like with spectrometry.
Unfortunately, at some scales, you get to the limits of what your brain can image, what your brain can literally imagine. Like the wave-particle duality issue. It's not that it is sometimes a particle and sometimes a wave, or that it is a wave, or that it is a particle. It is something altogether different, which is accurately described by the mathematics of both waves and now the fact that we can or cannot image
because you can't use light to visually observe something that is smaller than the smallest waveform of light. So I get that, Barney, but I mean
yes, but that doesn't mean that we don't know things about that thing, right? There are ways to measure things, there are ways to detect things, even though we cannot image them.
Well, that's why I was asking if you think the next breakthrough in science, as far as the understanding of the rest of it, will come when they try to create something that can see further than what they can already see, using some unknown detection method.
Naively, no. Like we won't know anything more about an electron if we can image it, if we can see it, right? That won't tell us much about the electron. Well, it might, but I don't see how. Based on what we know about the electron right now, about it's not even. The reason why I have such a problem answering your question is because it's not even a question. You're misapplying the analogy of macro to the micro. There is nothing there to be seen.
Let me put it like this.
Wait.
Get to the Higgs boson.
No. I just want to finish. In respect of, but do we discover more things by more accurately measuring them and detecting them? Yes, we do. That's what we do every day. That is literally what natural sciences, especially physics, is all about. That's what they do. Specifically that. They come up with new and better ways to measure and detect things. And then they measure and detect
Well, of
things.
course, and they also just increase the power. You know, I mean, so now the Large Hadron Collider they're going to pump it up, crank it up, put more power into it. Maybe we can break through something, right? I mean, that just seems a little cavemanish to me.
Well, it's not just that. So, as much as there are demands for just cranking up power because more power will enable us to see on smaller levels and making the instruments bigger and more convoluted, more intricate will let us see on smaller scales. So much so there are papers about new intriguing ways of detecting things. Like literally, again, weeks ago, there was a new paper which was tied to the Schrodinger cat experiment of potentially disambiguating between taking a measurement of seeing inside the box and taking a measurement of seeing whether the proverbial cat is alive or dead, and that we can put those two as two different questions and can therefore look inside the box without violating the. But all of that is backed up by methodology, by how we do it, right? It is possible. Same thing. It was presumed that it would be impossible to optically see an atom ever because of what you said, wavelengths of light. But no, a couple of years back there was a Chinese guy, I forget his name, who found a way that you can use weak scattering, right? You cannot detect it by a single photon, but you can have a lot of photons of very low energy passing nearby an atom, and the position of that atom will still deflect that light in such a way, basically single atom refraction, that you can get a readable image by optical light on the other side. So something that was considered completely impossible, and that this is very low energy, and you don't need a certain level accelerator. Optical light
So is this
detection of
that
atoms.
invisibility cloak thing?
No,
No.
this is not a matter.
For that invisibility deal. Is that what it was?
No. Nothing to do with invisibility.
And that was a debunk.
Well, it's not invisible. It doesn't make it invisible. It just reprojects what's in front of it behind it, so it looks that way. It's bending light.
That was phase redirection of light, but no, this has nothing to do with it. This is literally diffraction of light by a single atom. And then using that diffraction to reconstruct the image of the atom.
You have a link to that?
I can look it up. I don't have it on me. I'm standing in the park outside of my house.
Oh, never mind. I'll look for it.
Well, there's a channel called Captain Disillusion. He did a debunk of that video.
Oh no, that's okay.
No, I'm talking about what Barney was talking about. Is there a scientific paper website that you go and see these new scientific papers that people come out with? Is there?
Well, for some of them, I just, like everybody else, follow the news articles. But instead of reading the news article, you just scroll down to the bottom, and there's usually at the bottom a link to the paper, and you go and read the paper.
Yeah.
Right.
It's all about the citations.
But also talking to people who keep track of these things, you'll get notified when there's something interesting. Right. If you also if you follow channels such as PBS SpaceTime or SciShow, they will regularly.
ASSS.org? ASSS.org, is that it?
Is that what?
Oh, I was just I was wondering if you followed that one. Is it? It has
No,
a bunch of new new
I don't
stuff.
know.
You know. Cool. Well, my brain's fried for the night.
And if you find like a link to a paper and the paper is behind a paywall, there's kind of a peer-to-peer network for scientific papers, which is called Sci-Hub, SCI-HUB. And you just, you can Google like where Sci-Hub currently is, and it'll give you access to basically any scientific paper that's behind a paywall. European Union should next year finally implement the open research law that will make every scientific research which has utilized public grant money mandatorily be available to the public. So all the scientific papers and all their research data will be available to the public if they use tax money to perform their research, which will be great.
Is that just the EU? Is that just Europe?
That's a European law, yeah. That's EU. I don't know if the rest of the world will follow suit.
I hope so.
I doubt it. That's weaponized technology right there, boy. Got to keep the trade secrets.
If you want to have your military research, just do it. Don't publish it at all. Don't do it within the military, right? Don't do it within the scientific community. Do it within the military community. That happens. You can still classify things within the EU, even though it's tax paid, right? This is just for scientific grants.
Well, I think I'm going to end the stream on that one. Thank you, Barney. I do definitely, I mean, I can't appreciate it enough how much you help make things basic for a lot of us, and especially myself. I've definitely come to the conclusion that the topic of space-time isn't going to be just answered or all-knowing. I don't think it's possible. But it is something. We know that. Does anyone have anything they wanted to promote or anything? They and them, you guys going to be streaming soon?
I promote that I'm going to go to sleep and that I froze my ass off for this.
Thank you, Barney. I appreciate it, my friend.
That was
Thanks,
fun.
Barney.
Thanks, Barney. Yes, there's a couple of things in the works. Hopefully, something quite big. Just waiting on confirmation for a few people, but I will let you all know.
Cool. Awesome. Sounds good.
Thanks, everybody.
You were roboting, Maxwell. You want to say it again?
I was just saying thanks to Barney and you
And the robot.
Is I still roboting? What the hell?
Yeah.
I was just saying thank you to Barney and thank you to Shawn and thanks to the rest of the crew.
Thank you, sir. Appreciate it. Anybody else? Shawn?
No, I just wanted to say thanks to you and everybody else on the panel. I just sat back and listened. Sat in on the chat for a little bit. It was it's trying to fit all of this into a little 2-hour session is like possible. It's unbelievably hard. Just wrapping your head around like I said at the beginning, a 3-dimensional object is hard enough, and then a fourth dimension added in, you're gonna be pulling your hair out.
God, please don't say that anymore.
Well, what if I told you there's 5 dimensions? No, I'm just kidding.
I'd be okay. I'd be okay with 3.1 dimension, but not 4. Okay.
Okay, well,
They
we'll leave you with this.
You cannot conceptualize a 4th dimension mathematically or mentally.
Well, how about this, Maxwell?
That's still up for debate, and we can worry about that later.
Well, I'll leave you with this, Maxwell. If string theory or superstring theory, as it's called, ever does come to fruition, then we're talking 11 dimensions. Unpaid, you got anything?
Oh yeah, I agree with that. You know.
Yeah, I'm hoping for superstrings to come into fruition. That way I can just watch 7 billion minds explode all at once.
Exactly. All right, guys, I'm going to get out of here. So rude, I'm eating. All right, guys, I appreciate everyone for being here. It was a fun one. Got to learn or got to hear a lot of different views and ideas of how things are. But the reality of it is no matter how we think it is or think it's not, it still is. I think tomorrow I'll be going live, but I'm not 100% sure on the topic, but it may expand into this a little bit more. I'm not 100% sure yet. I'll probably see how the views go in the comments. Make sure you guys like and share this, please. I want to get this more eyes out on this. I know over the past few days we've been getting I've been doing a lot of joking around and stuff, but there is a point where I'm going to get back to the seriousness of it all and more topic based, like I've been trying to do. I just thought maybe it'd be better if it was a little less serious for a little bit. Wanted to relax everybody, but we're going to get back into it. And again, and just enjoy the time that we're here and enjoy the information that we're able to get. Because realistically, we don't know all we want to know all, but we're going to need a lot more time for it. So with that said, guys, I appreciate everyone that was here, everyone that was on the panel that was helping out, and I'll see you guys tomorrow. Thank you.
Thank you.